Hi everybody, welcome to the stream. Just need a minute to set up real quick. Excellent. Alright. Hi everybody. Today is another day. Yes, the start of a brand new week. Oh boy. So today we're doing something a little different from what we've been doing for the past few days. That doesn't mean we're not coming back to this because we still got plenty to do in terms of making the spellcasting system for monsters, but I figured we were having a little trouble with debugging lately, and part of that is because we can't jump into the game quickly enough, which is a big problem. Now, one solution is to just put the monsters in like a small test stage. That way it doesn't take long to load that level. But when we're talking larger stages here, we're currently running into an issue where it just takes a while to load, and it's not just for debugging purposes. This is also the real game. While the real game doesn't take very long to load because of all the optimizations that the compiler makes, we still run into that issue of it takes some amount of time, and this is a kind of a struggle point for the game. So I want to take some time today to focus purely on optimizing the game loading code. A lot of why the game loading code takes a while is because we have a lot of pre-processing to do on the maps when they are loaded. But you can prevent a lot of this by caching all that data and then just loading that data in, and it's already pre-computed. It's just these pre-computations take a lot of compute power, and because of that we end up having longer load times, which could be minimized if we did this correctly. So let's get into optimizing that today. Now, when it comes to optimizing anything, before you just go in and start modifying code that you think is slow, you need to actually profile your code and see what is causing the holdup. Because we don't actually know. It could be like one simple call that is hanging up everything, and everything else is super fast. And if we just go in and we're going to optimize every single for loop and variable and constructor and function, now we're just kind of hoping that some of these changes create benefits, and some might even get slower if we try to optimize out the wrong things. So we have to be very careful about that. So the most important thing to do if you are going to optimize anything, any slow points you find, is you need to properly profile your program first. So that's what we're going to be doing. Visual Studio comes with a program profiler, so we're going to be using that to trace the hop paths in our code. Hop paths are just any code that is frequently accessed and take up time. The more compute time it takes up, the hotter the path. And we're trying to find the hop paths to figure out which lines of code give us the most bang for our buck when it comes to optimizations. So the place we're going to go for our level loading is the load level function. The load level function has an internal function called _prepare level. So load level is what we call when we're like, oh, I want to suddenly load level 3 or level chapter 2-6. And then prepare level has all the code related to actually running that loading. This is just a front-facing function for what actually happens under the surface. So as we can see, this is pretty involved, and how this works is we actually have a loading screen class. So to make a loading screen, you have to at least if you wanted to indicate any visible progress, you need to know in advance how much you have to compute, right? And then have a meaningful progress bar that fills up. Progress bars are usually lies. They're just there to make sure the user has a better experience when it comes to loading, knowing that their game hasn't frozen and that something is still happening. And that's essentially the function of our loading screen, is while we do have a couple different phases, the whole goal is that every once in a while in our computation loops, we actually come back out of it and update the screen. That way the player knows, hey, the game isn't frozen, we're just taking some time to load. But as you can see, these are pretty involved, and the way this works is I add in a bunch of phases in the loading screen with lambdas that run certain code. And I split them up so they are kind of evenly matched out. Like different parts take different amounts of time, but ultimately we're trying to just split them up into meaningful chunks to where the player knows, hey, we're making progress, we're halfway done, we're a quarter of the way done, we're almost done. So in here, if we're just looking generally through all of our code, we're going to find that a lot of this is related to loading maps and messing with the tiles. We have to specifically group up tiles that are considered objects. We have to identify what the collision masks of the tiles are. Basically, you know how there's that effect where if we go behind like a tree, it fades out? How do we know in game to fade out that tree and not just one particular tile? We were actually running into this issue earlier. I thought it looked kind of funny where like 1 or 2 tiles of a tree would start fading out, but not all the tiles. And that might be okay in a game where you don't really care about like depth, but our game has a little bit of depth, and also it needs visibility is very important. If something's blocked by a tree, we consider it pretty unfair if you can't identify what's behind a tree just because it's sitting there in the foreground in your way. So a lot of the tiles actually get grouped up together so that if we fade out one tile of a tree, we're actually fading out the whole tree. That way you can see behind it. So that's a lot of what these do, and there are 2 layers, so there's a foreground and a background layer, so we technically do this 2 times, and there's even upper foregrounds and lower foregrounds. So we have a lot going on here, and we need to figure out exactly what is causing the holdups. So what we're going to do is we're actually going to run or build our game in debug mode, because in debug mode, we are able to realistically get an idea of what is causing performance problems while we're in debug mode. Now, naturally, if you're actually trying to profile, you also want to know what you can optimize in the release build, but the release builds already get optimized out a lot, so you're more concerned with at least identifying what code paths get hit often, regardless of the optimizations or not. You just want to know in general, hey, how often is my code being called, and what can we do to reduce that? So sometimes I will performance profile in release mode. Obviously it's a little stranger, because sometimes you'll hit code paths that are optimized out, and you're like, well, I can't really do anything about that. I can only optimize the stuff around it. But that usually gives you hints as to what you have to optimize, whereas if you do in debug, obviously you're going to get line for line what you need to do because the lines aren't getting optimized. So generally, performance profiling in debug mode is a bit more beneficial. So I am going to open up the performance profiler here. I'm not going to start it until we're loading a level. So basically, once this thing's ready and the game actually starts, I'm going to go ahead and breakpoint right where load a level gets called. So we're going to breakpoint right here where the loading screen reset line is. And then we'll go from there and profile it. So, yeah. Visual Studio has a nice profiler, as I mentioned, so it will point out a lot of the code hangups we have. And then we can figure out what to focus on and optimize. Because it's better for us to know what to optimize than to guess, right? We could easily say like, oh, this giant for loop inside a for loop inside a for loop, what can we optimize here? But then it's like, where do we start? Is this really the slowest piece of code? Is it here? Is it the insert tile function? Is it when we iterate through other layers? We still don't know exactly, right? We would be guessing, and guessing is not good. It's not a good use of our time. So I'm gonna go ahead and do this. Now technically there is a load level at the beginning because it loads the introduction stage, but what I would really like to hit is a level that is very, very involved. This is a very small stage, so it's not a very good representation of what a loading time would be on a very beefy actual map. So 4-1 is a very large map and is the one I was having trouble with when I was debugging on Friday. So we're going to use this as our profile test. So as I mentioned, I'm going to add a breakpoint right when loading screen reset is called. We're going to go ahead and hit the start button here, and we can immediately see that the breakpoint does hit, so now we're here, and this is where we want our code to be. Now, ideally you also put an end breakpoint, so you're only profiling the stuff that you care about. So what happens at the end of all this? Well, when loading screen is done, it will completely return everything and then proceed. So let's go into the loading screen class, and you'll see we have defer load, we have an update. So we're going to look at the update function, and in here, when loading is false, we call state on level load, and then we're done. So I'm actually going to breakpoint right here because this is where our loading is complete. And this is what we want to optimize today, so this is our stopping breakpoint for our profiler. So, now that we've done all that, I'm going to hit start on our profiler. We're monitoring CPU usage here. You can also monitor file I/O, GPU usage. We'll also be profiling memory usage, although that's not really useful here. At least, I don't think it is. Hi there, Adrian. Welcome to the stream. Happy Monday. And right now it also says start with collection paused. So we'll go ahead and hit start. The collection session cannot be launched because another one is currently active. Oh, I think I have to start the... Or hold on, I might already have it open here, diagnostic tools. And let's go to... Okay. So I want to go to CPU usage, enable CPU profiling. So yeah, this is effectively the same thing. I was just in a different spot. So right here, this indicates that we are currently recording CPU profiling. Oh, thank you very much. I appreciate that. So I'm going to go ahead and hit continue now, and the game is going to just run its thing. You'll actually see here in the diagnostics that all the CPU meter turned green, indicating that it is currently recording all of that section. So that's going to be useful in a minute here, because this is actually identifying all the calls that are happening during this loading time. But yeah, thank you, Adrian. I will be doing the Grandma's Endurance Stamina Marathon on Friday. So I got one more to do, and then that's it for me for Girlpocalypse. I decided not to do the ITG Tech or Timing this year. I'm not a big fan of the charts and songs they chose, so I didn't really feel like doing those. So Grandma's Endurance is taking like really like old school throwback charts from like the beginning of the ITG days that were stamina charts, and they're all combined into one marathon. One of the biggest features of old endurance charts is they would have a bunch of like step jump or bracket tech in their breaks. So your breaks aren't like errorless breaks, and they're not eighth notes. They're like step jumps and brackets, like actual charts. And sometimes in more rude charts, some of your slower stamina stream charts also have crossovers in them. So they would be like mini Stamtech charts. Okay, so we can see our breakpoint here where loading is false has been called. So this is the end of our CPU profiling. We don't care about anything else. So we're now going to hit open details. And we're going to analyze all the time that was recorded here. Can I zoom out? Yes, so I'm going to zoom out and get this recorded chunk right here that was recorded. And we're going to take a look at what the profiler says about them. And then from here, we get to analyze the hop path. So right now, let's look at the flame graph, and we can see this is a breakdown of all the calls within my program. Yeah, so in here, this is a good breakdown because we can see that, first of all, most of our program is being handled by on-user update, so we're going to go ahead and zoom in on that. Loading screen update is taking most of the time, as we would expect. We'll keep zooming in on that, so you can see this has turned very bright red. This means that it is a very hot path. It is about 60% of the calls here, which is what we would expect, right? This is the load function, and then it starts getting divided up here. So this is what we're currently interested in. I'm now going to switch to, I think, the call tree. Let me see. I'm looking for a very specific view. Okay, functions. So, in here, it's like a breakdown again. So we had loading screen update. I think I should be able to go further. No, this isn't what I'm looking for. I think I really do want the call tree. I just didn't go in for far enough. But yes, let's dive into this. So we're down to on-user update, and then we're into loading screen update, which is again 60% of the calls here. So it'll tell you what percentage of CPU was being used for these calls, and as you break down further and further, it goes on. Also, I'm going to click this, show hot path. I think it's going to reveal, and let me expand hot path. There we go. So you can see here it has little flame icons just to indicate, yes, these are the hot paths. So this takes up 24%. That's pretty significant. We have a 24% here, and then we have a 10%. You can see these are all lambdas, so they're unnamed anonymous functions. But if we were to click them, then our source code, well, if we go into them, it'll tell us the source of these lambdas. So that ends up going to right here, lambda 10, under pathfinder.initialize. So that's interesting. We have a pathfinder script here, which is running, and that's taking up quite a bit of CPU. 25% is a lot. So our pathfinding code, which is pretty standard for pathfinding code to be expensive, so that's expected. But we can go even further, right? And we can, once again, I can hit expand hot path, which will give me even more things. So we can see under get tile collision, get tile sheet, that is where a majority of this cost is coming from. So get tile sheet gets divided further, and we can see this turns dark red here, where it's like, okay, 5% of the cost is here, and maybe I'll put this in another tab. Well, I would like to open this up in another window. Or, excuse me, not this. Where is this? Here it is. I'd like to open this up in a separate window so we get a nicer full view of it. I don't know why I did that. Yeah, so we get a better picture here. Ooh, okay, good luck. Have fun. So yeah, this one's pretty big, and my guess for this one, and as far as I can tell, is we have a couple of string additions. This is a lookup. I don't think that would be that expensive. So my guess is the string addition is probably the biggest thing. But let's look a little further, because we can see here we have basic string constructed. That's again a 5% there. And we have to keep in mind that this has happened hold on. Yeah, this has been called about 5,000 times. This one is... like, this function right here has been called 24,000 times, so 19,000 calls, and then the 19,000 calls is broken down into these, so it's quite a bit. Profiling! Yeah, we find out our awesome code is not so awesome anymore. So yeah, this is my guess. This right here, this addition, is costing us a lot, because it's basically assembling a new string each time. Now, can we do anything about that, is the question. Well, I see right here, we have a standard string. Basically, we create a substring here based on source from tile data. This is like grabbing at what the source tile set is from a particular tile. Like, we're grabbing this from tiled essentially, this data. So this is trying to identify which tile it comes from. And this is a combination of all of that put together, which, as we can see, is kind of expensive, especially as we iterate through every single tile in our game. Yeah, most of these, so yeah, standard map also takes quite a bit. So that's 2,755 calls as well. So again, all the things in this function is amounting to, it costs a heck of a lot. So that's one. That's not all of it though, that's only 25%, right? So we can look a little further at lambda 6, which is another 24% of our load level function cost. So I'm gonna do an expand hop path here, and it looks like it goes down to, we have 12,000 calls in standard less. This is from a map. So let's take a look at get current map and what it does. It calls map data.at, and we can see the 15% is down here. So this is like this call itself, because it has to look up in a map what it needs. So get current map reads from map data, which calls get current level, and get current level. Can I open you real quick? Oh, maybe that's popping up here. I don't know where this is popping up. Get current level. Okay. Is this a safe map? Or is this just a map? This is a standard map. If you can get away with it, unordered map is more performant. Yes. And in this case, we can get away with it. So that would be a small little fix there. Map data, I think can... So, funny enough, when I was first designing this game, like 3 years ago, I had no clue about unordered map. So a lot of my old code only uses maps when there's no need for the sorting capabilities of a map. So a lot of that can be reduced just by doing that, because that standard less is why it's being called. It's like, that's a comparison, that's an operator, string compare, like you can see it all adds up little by little, but it starts from map. So that might be a good idea to start with some optimizing, is just converting some of these maps into unordered maps, especially with how many times we call these. So I guess I'll start there. That's simple enough. It's a very easy thing to do. We also have 10% from Lambda 4. Let's just take a look real quick out for fun. We have a minimap reset call, which goes to minimap update chunk. Now this one I can expect to be a little costly, because we have to do like some sprite manipulation and pass that over to the GPU. So I can expect that this one, being image manipulation, gets a little heavy. It's not terrible, but it's definitely not cheap. I don't see the expensive part here though. Let's take a look further down. Also, hello Monster UUU. Welcome to the stream. Okay, it looks like there's 4,299 calls here, which is 4% of it. And we have get tile collision. And get tile collision, yeah, we can go a little further down here. And it looks like it's just mostly spread out. Get tile sheet again is a lookup. I think I can pull that up in the same file. So yeah, it looks like this. It returns tile sheet data, and this is actually a copy. That might not be what I want. Why would I return a copy here? Oh, well, even so, we're not gonna like keep this data around. We don't need to reference it in the future. Why not just make it const ref anyway, because it's only gonna be temporarily used. That doesn't really matter too much, but I don't see a reason why we have to make an individual object out of it. This game is called Adventures in Lestoria. It is spelled like so. That's what it is. So yeah. is a game I'm currently working on. It's an action-adventure RPG, and it's just a little fun project I've been working on over the last 3 years. Today we're doing some loading screen optimizations, so fun. We're currently profiling, just getting an idea of what is costing us CPU cycles. Once again, we have a string that gets built. We have an S2I. Okay. So one thing I was expecting out of all this is that eventually we're going to get to the point where we want to just turn all this processing that we're doing at the loading screen into data. If we turn it into data that we can just store, then we don't have to do all this processing in game. We just load the data manually. So it's like, in the worst case scenario, the speed can't improve enough to my liking, then the next best step is to offload all this pre-map processing into another program and run that program on all my maps to generate like a cached map with all the data already loaded, and just load that file, which is a lot cheaper than doing all the calculations and processing on the fly during runtime. So that's kind of what we're aiming for today. We're just getting the big picture right now. But at the very least, I will return to the header here and adjust some of our maps to actually be, we can get there, unordered maps. Because we don't actually need the sorting capabilities of a map. So we can switch them to unordered maps. So we don't need it there. We don't need it here. And I believe there was one more that was important. Maybe I'll do a quick search for standard map. A zone list. I mean, might as well. That's the ordering of that is not important. Get zones, get zones. Yeah, that's gonna be a getter that returns, so we have to adjust those. Get tile sets. And if we adjust these functions, naturally, we have to change their definitions as well. So that's gonna be that. Gotta go up a little here. Gotta fix these. And then anything else, map data should be an unordered map now, so that should be okay. Okay. IntelliSense just catching up. Let's get out of debugging. Try a rebuild. That one's gonna take a little bit of time because it's adjusting some major header files. Yeah. But looking at a lot of the code here, we're definitely going to have to rethink how we do some of this loading. But I'll be honest, I don't think switching these to unordered maps is going to result in much in terms of actual load speed increases, but you never know, right? You never know. That's the thing with profiling. It's like, you look at it and you're like, you know, I didn't expect X or Y to actually be that slow, but it is. You'll be happy I took what I learned about CMake from Hamster Planet to the multi-header PG3 stuff, including the headers as well as the source files. So header changes trigger rebuilds. Oh, that's good. Yes. That's very good. Because yeah, that was a pain point when it was first made, and it's like, I think I did, because it was like in a game jam setting, I think my fix was to just quickly make another project and copy everything over or something dumb. Like, it was definitely not legit. Okay. Alright, so if you're gonna implement it this way, you need to have a binary equals operator. You need to be able to copy, wait. What is this saying? Hold on. We're trying to copy a structure? Why is that? Standard map. Okay, zone data is an unordered map, so that doesn't work. I'm like, wait, why are we copying that? That doesn't make sense. I think the only requirement for unordered map is that the object is hashable. Okay, was there anything else? I don't think I saw anything else. I think that was it. Whatever else popped up was just cascading. Okay, but the cool thing about fixing or optimizing these things is once you optimize something, it just shows you the next hottest path. So you can do this forever and ever and slowly optimize your code as much as you want, because you can literally do this process over and over until you're down to microsecond optimizations where it's like, okay, now you have to do something really dumb to get any more speed. I like that analogy. That is a very fun analogy. Yes, your first run of a speedrun is typically very slow and nowhere near your true capabilities. Cannot convert from const unordered map. What is it trying to do? Oh, okay, yes. Just more propagating fixes need to be made after we did unordered map, or ordered map, excuse me. And there's a couple more here, I assume for the exact same reasons, so I'll just do this now. Yep, there's one there. There's one here. And there is one more here. 5 years from now, people are finding sub-second optimizations. Right? Okay. Or our compilers just get so good that they also find their own optimizations. We also logicked out that this to-do doesn't need to be here. We were figuring out why if I moved in the... I think it was if I moved in the Y direction but not the X direction, why I'm not... Or if I move in the X direction but not the Y direction, why I'm not checking for the opposite. And it turns out that this right here is actually redundant. Because if we can't move in the X position before and we can move in the Y, then we check the X again, there's no reason to check the Y. And if we moved in the Y or in the X, then we only check for Y one time, we're never going to move in the X again. So this is redundant. It just looks like at first I'm like, why didn't I consider the Y-axis? It's just the Y-axis is already considered. That's just how it is. It's a little confusing. Because it either you set the X before or you set the X after. But if you set the X... If you didn't set the Y before and you would be setting the Y after, well, you couldn't move there before. Am I just rambling now? Let me see. Hold on. Yes, we only try to move in the X again if we've already moved in the Y, but we don't... It's basically to allow diagonal movement without allowing extra diagonal movement, if that makes sense. If we did this again, we'd actually break movement. Hi! YouTube put your recent streams in my feed. I love me some C++ learning. Oh, awesome! Welcome, welcome. Yeah, I've been getting a lot of folks coming into the stream. I absolutely love it. Overload function defers only by return type from const map. Did I, like, forget to change it? Let me see. Or is zone data still ordered map? No, that's an unordered map. Zone data is good. Gets zones, though. Okay, this is the one we missed, yes. The declaration of it was incorrect. Hopefully that's the last of them. And yes, while unordered map is a little faster, I don't think it's going to be the performance increase we're looking for. The paste woes. The paste woes, but also working on big codebase woes. Had to change one thing in like 5 places. It's like, oh, I'll just make this a different structure. Oh, I have to make a different structure in 10 places. Oh, definitely not. For sure not. Yeah. But let's take a look at what it does improve, and maybe it'll just show us, hey, new hot paths for you. Get to work. But if looking up from the map is still that expensive because we do it so much, then going with the pre-caching method might be the best option for us. Yes, the string concatenation looks very concerning. I'm currently thinking of what alternatives we could go for. We could either like store the base, because what it is essentially it's adding the base directory to it. So it's like we could include the base directory in the original string we're reading from the file. We could... A lot of it is going to be repeats, so we could also cache the concatenated strings in a map, and then once we have constructed it once, we don't have to keep reconstructing it. So that's another option that I think is pretty easy to implement. Like doing the whole... Basically taking the entire loading process and putting it into its own program would be like the nuclear route. It's the route we go when there's clearly no other way to optimize this. We're going to have to take the cost and just front load it. Do it on the preloading end and store that data to actually load later. Yeah. Because a lot of those tile sets, it's like, okay, it's going to be the same file name. Why am I reading the file name and concatenating it over and over and over? That's where the real cost is, right? So, let's do this one more time. Oh, we're done here. Can I get rid of this? Or did it just record everything up to... Okay. Stop, please. Okay, so it's disabled right now. Well, now I want it enabled, but now I need to... Maybe I can just clear this, I think? Help. Like, I don't know if I can... No. I'm just gonna restart it real quick. I didn't realize I left it on, so... And I'm also just going to hit Performance Profiler this time. I guess I'll run into the same issue, but I'll make sure I stop it this time. So it's currently disabled, I think. CPU usage. Okay, I'm gonna hit stop collection. No, I did this backwards again. Dang it. Okay, yes, I did it right the first time. I just didn't stop it from the previous session, which is where I got confused. Oh my god, my computer's freaking out. Okay. It's also pretty expensive to run and parse all this stuff. The profiler itself has to do a lot of work. Naturally. Okay, now I don't know where it went. Because this is the CPU usage view, which I don't need. Where's the diagnostics? View. Oh, also we're gonna skip this initial breakpoint. We want to go to the next breakpoint. Okay. We are most interested in that. View, resource view? No. Where is this? Resource Explorer. Code metrics. That's not really what I want. I mean, that's eventually what I want, but not yet. For sure. Oh, resource view. Wait, no. I just did that. Code definition window. Class view, bookmark window. Where is this thing? Window. Restore closed tab. I didn't know that was a thing. That's actually kind of handy. I don't know where my resource window went. It's supposed to be called like resource window or something. Toolbars. That's not it. Help. Resource Explorer I don't think is right. That's definitely not it. Oh god. Alright, what's it called? Am I gonna pull my VOD for this? There's only like 400 different things in there. Which one do you want? I think it was called Resource View, I'm pretty sure. But hey, yes. You have a perfect case in point now. And why don't I use Visual Studio? Oh, I don't know, because of this? Oh, diagnostic tools. Okay. I don't even think it's in here. I think it's in another place. Dialog editor, debug. I should have looked in debug first. Here it is. Well, that was fun. Also, apparently I have to restart the session for it to actually do it. Okay. Yeah. Naturally, with 10 billion features in it, that's what ends up happening, right? And I'm sure among all these hundreds of features, plenty of stuff breaks under the hood all the time. Like, imagine the developers that maintain this project. God, what a mess. Like, I remember, for about 3 weeks, multi-selection did not work. It would literally just highlight from where you selected your cursor to the end of the cursor when you tried to multi-cursor select. And I'm like, that's weird. It didn't do that before. And then I found like some random like bug report thing, like bug report 400,000 something that was like, oh, this is a very recent bug, so until we fix it, you just have to deal with it being like that. Yes, maybe they should use the tools they make so they know when it's broken, so they don't keep breaking it. What a great idea. I mean, I'm sure they do, but at the same time, like, then it breaks and they have to code the fix, and then maybe the fix that they coded using the editor they coded it with might break something else. That would be funny. Okay, so we're here. This is where we want to profile again. So I'm going to go ahead and now enable profiling. And then we'll go ahead and run all this again. And we'll see what happens. I use Visual Studio at work and it's great, but that's for C#. C# clearly gets a lot more love in Visual Studio than C++. Like, you can immediately tell when you start using C# in a Visual Studio. And partly because C++ also is a much more, well, maybe not much more, but it's definitely a complex language to where I don't think they wanted to give it as much love as C#, which is like their baby. Yeah. Using C# in Visual Studio, I'm like, am I even using the same program? Like, everything's different, and it's like, it's definitely fancier. It's like being given the high-class treatment. You try to use C++, it's like, well, now you're on your own. Good luck. It's just the editor that's the same. Okay, so we got this again. Let's take a look. It didn't really feel faster, I'll be honest. That felt like it took just as long, so... Case in point, changing to an unordered map probably won't do much. Let's drill into this real quick. Oh, this is... What? Keep going, keep going. Is this in... Hello? Game Overlay Renderer 64.dll. Am I in the wrong... thread? Okay. How about we go in here? That would help. Okay, I'm just gonna drill down into loading screen here so we can go further. I don't know why our call tree... I must have opened the wrong thing. For some reason, call tree... Oh, I did, yes. I opened like a... What do you call it? I just opened a random thread that has nothing to do with it. It's the controller thread. Okay, anyway. So Lambda 10, 6, and 4. So the same lambdas as before, naturally. They are still the most expensive, that doesn't change. And we still have the standard basic stringing added. We still have a standard map call there. But yes, it's the constructing strings and adding strings that's the problem there. So we could, again, try to fix up the string construction. I don't think that would be terribly hard to do. And if that's really the biggest speed cost, then that's not too bad. Here, under get current map, the standard tree, which is our map, has gone down. It's not the most expensive thing anymore. Get current map is still accessing a lot from here, so it's just these two still have pretty high accesses. So it's just a high cost no matter what. And then we have this lambda with the get tile collision, still the same thing. The lookup is expensive because there's a lot of them. Again, here with the string constructions, that's still expensive, just in general. I basically learned what CMake was through Moros, because he provided a CMake configuration for the OLC Pixel Game Engine community. So, which is what I'm actually using in my project. It's like a template for setting up and running OLC projects. So because of that, I use it for the my Pixel Game Engine project, and it works very well. It makes it easy for me to just compile for all my systems with relative ease. Mission accomplished. Yay! Okay. So string constructions are pretty bad. We realize this. Let's go for caching them first. If we can keep everything as is and just optimize some of that, I think we'll be okay. So let's look at lambda 10 first, which is, I want to say, there's so many lambdas. I should have wrote down like what the actual lines were, but let me see if I can locate them again. Well, I know one is get tile sheet. Let me see. Yeah, get tile sheet. It's this line right here that gets called very, very often. This one also has it, but typically we don't have an invalid tile, so, which is essentially what this is. So in that case, we're usually calling this line right here. But we can see every single place we have slash assets, or assets slash map slash whatever the base source directory is, which is retrieved every single time as well. So something here needs to be cached and used over and over, because this is not going to change very often, because this is going to be the same tile set. It's going to use the same image every single time. So what I could do, I could locally create a map here which just caches everything. So a static map for this function specifically. That would be a very simple way to go about it first. So we'll just start there, and oh, I'm also typing in Korean. And if we like the results here, we may pull the map out, but there might not be a reason to. If it just locally needs to cache the string, then so be it. Once it's cached, we don't have to reconstruct it every time. So essentially we're looking for, what should we look for? Well, this is all based on, yeah, we gotta figure out what this is all based on first. So this is essentially looking up what the directory of this tile map comes from. Tile data, tile set data, and then from there it's saying find the last slash, and then that's the slash marker source directory, which its substrings up to there. So I feel like this in itself, that's interesting. Because this, if we want to look at it visually for a second, what all this even means, I can go to here, and we'll just pull up one of these real quick, just as an example. So here we have all of our maps, and we're specifically looking at the TSX files. Each TSX file comes with an image and a source. That's where that source key comes from, is when we read that, we're reading the source key essentially. And you can see the source key has that commercial assets slash chapter 5 whatever, blah blah blah. And it's that commercial assets that we're parsing, I guess, from, or reading from. So we're looking at commercial assets slash, and then we're grabbing everything up to there and filling that in here. So it's gonna be like assets slash maps slash commercial assets slash, and then whatever else. So I don't really know why I did all that, because where else are we using this? Oh, I would also like to point out, and I'm sure this gets optimized out, but these two strings are also similar. Thanks, Moros. Thanks for stopping by. Also, I like that idea for making sure it stays updated from the main repo, which is awesome. New C++ features for path and file handling, that would be nice. Standard file system is already pretty good. What I would really like to see is the capability of being able to read in stuff on compile time, because that would be pretty cool. Like, imagine if you can const expression all of your like game's data and preload it all while you're compiling your game. But I guess that also leads to the inflexibility of your files now aren't live files, but it could be a fun experiment, having like a const expression for data that you just want to store externally, but you don't want to, but you still want to load into your program. I think that would be fun, but then having a runtime function for, I think that's what const eval is for. I'm not entirely sure. I could be wrong about that, but I think if you have a runtime version of that function that can then reload stuff, I think that would be a very flexible system and could be very fun. But it would also speed up all the like internal stuff where it's like, oh, I have to read this in, and if that's const expression, then this can be const expression. You can calculate a lot of stuff on compile time. That would be fun. I could see a lot of uses for that. But that's just me rambling. Let's see here. So, I still have to understand what we're exactly doing here. Because, yes, we know the location of the last slash, which means this is like the directory, we found that. Substring it. Okay. So we're essentially getting everything up to the slash here, commercial assets. Appending that here, and saying, okay, that is tile sheet data. Review this real quick. Tile sheet data, we have the tile set name, first GID, and the tile color. I'm not sure. Oh, this is the index it starts from. Okay. So that makes the tile sheet name chapter 5.1 PNG, which makes more sense. So essentially, if we can just read that right out the gate, that would be nice. So basically we're saying, okay, if we find, what is the constant here? So like map, right? The map name. If we store that in here, then all the other data will be the same after the fact, because tile data will be the same for this map. If we change map, then the tile data might be different, and so that will change all these functions. So that's essentially what we're looking for here. But I notice here for tile data, we also go through an index, so this is like for every single one. Okay, so this is if the size is 1. It's typically not 1, but if it is, it just gets assigned a first GID of 1, otherwise it gets assigned a first GID. Yeah, this handles the case, like you can see here, there's no first GID, and I think that's intentional when there's only 1, but if we open up a TSX with more tile sets, you can see here, okay, first one, that's fine. Let me find another one. Oh, this one only has 1, okay. Let's try. What would have multiple images? I wonder. Or do all these only have 1? Am I looking at the wrong thing? Tile set data. Source. Maybe I am. Hold on. I'm not sure why I'm having problems with this. Maybe I am looking at the wrong thing. Campaigns? Okay. Here we go. This is more what we're interested in. So yeah, the first GID is here. I assume if there's only 1, maybe the first GID is not specified. Like, what would we only have using 1? I don't think we have anything that uses 1, unless it's like a basic map. I don't see anything that would use that though. Oh, here we go. But even then it does have a first GID tag, but I guess I just include the one. But yeah, standard file system just... I think the power of standard file system is it just makes it easy to access files, regardless of file or OS. So that's a very good abstraction, that's very powerful. Makes it so you don't have to remember, oh, on Linux you have to use, what is it called? I just know in C, like, there's something you have to do because it's like a POSIX file system or something like that, and I think that requires a different header. So like, if you're trying to access files in a different operating system, you just get this mess of like, oh, which I have to include a different header to read files. So it's just an abstraction. But I would like to see what else they do with that. Also, standard file system path is very handy because you can just list out your system directories easily and then quickly chain like file system paths together, so you're essentially navigating up and down the file system tree, which is amazing. Don't have to remember weird syntax, you just literally chain them back to back. And that's always nice. It's very intuitive. The last time I played with it, I really liked how it was done. And even in my games, sometimes we have to do that, because at least for Mac, the required headers I need are different for if I'm trying to do Steam compatibility, which is a whole nother rabbit hole I have to go down eventually. Game currently does not compile for Mac. Like, the base engine does, but not all the features of the game, which is pretty natural. Okay. So I think I'm starting to see what's going on here. We're grabbing the substring of everything after this to grab, like, whatever TSX file we're interested in. We also have the GID here if we need that. And by default, if we only have one, we're drawing from tile data 0, but if we have a different tile data index, we have to reference it from that tile data value instead. Now, my question here is, what do I have to change to make sure this is always the same? So in this particular map, these will be consistent. Like in this map, these will never change. So if we realize that this I indicates which one we're looking at. If we realize that for one I, we have a certain value, then for another I, we'll have a different value, and so on and so forth. And that's how we can make index our unordered map. We can literally do it by the index here. So I'm actually going to switch it to a size T. That's a good indicator for me that it is indeed an index. And based on the size T, we will return... Do we only care about base source directory in the end? It looks like it. We don't need any other piece of data. We do need the first GID, but that's cheap to get. That's just an integer read from a map. And so I think what we're going to store here is the base source directory in the end. To make it more clear that's the case, I'm actually going to call this the base source directory with a using. That way I know what the key actually represents, because the string would be vague. And I just want to make sure I'm understanding what this map is actually doing for us. In this case, this is a cached string. Cached strings. And we can go one step further and call this the cached source directories. Source, or do I... No, the goal is to get rid of this. So it would be like the cached file names, I guess is the way I would describe that. And then from here, we can use it simply. If it doesn't exist, we're going to calculate it. If it does exist, call it. So it will look something like this. If not, cached file names count. In this case, it would be a 0. We're just gonna stick to that index for this. Else, we'll go ahead and return using that actual value that we've already pre-calculated. Hashed file names 0. I admire your patience. Oh. Yeah, of course. I think as a programmer, it's very important to be patient because programming is a very complex and logical process. It's going to require a lot of patience. If you don't have patience and get frustrated easily, then programming is not going to work out. And I've tried to work with a lot of people, teaching them programming for like college work, and probably that's the biggest thing I see is folks get too easily frustrated and impatient trying to learn and understand their code. And especially when something doesn't work, one of the most instinctive things they like to do the moment their code blows up and doesn't work is they immediately want to go to it and they want to like type in something different, some like random command they learned from class, or like they're like, oh, maybe it's this punctuation mark, or maybe I didn't tab right or something. And I'm just like, no, slow down. You have to read the error. You have to understand what's going on. Take a breath. Don't just go changing everything. Don't remove the -1. Don't change I to a J. Like it's just like it's something I see so often, and I find it fascinating, but also like I can understand why, because the impatience gets to people really quick. So you have to be very patient when it comes to coding. Okay, and then down here, let's see. So the index is clearly I-1. But I also notice we're grabbing this down here. So this, again, the first GID stuff we don't have to touch. We only care about this right here, where we're going to end up replacing this. So again, we essentially do the same thing. We're going to check if we have that index already. This time it's I-1. And if we don't, if we do have it, then we're already pre-calculated. So we can do this, like so, and just have those pre-calculated like this. Cached file names, I-1, and the same down here, and right here. And in theory, that removes a lot of the string constructions after the first one. Nukebird, I see what you're doing and I read your about section. I'm impressed. Stay cool. Oh, thank you. And thank you for the follow as well. I appreciate that. Okay, so down here we have the same thing, and this time it's tildata.size -1. Interestingly enough, it looks like I don't do the last one. In this loop, I do it down here. Which I guess my logic was we always have at least one, and then iterating through the rest, it ends up being first GID -1. So that's fascinating. I feel like these two, like this block, can incorporate this down here. I just probably did this because I found a bug and jerry-rigged it. Like, I probably really just jerry-rigged it in there. Like, that's why this exists, because essentially what this is saying, like, let's say the tile data size is 5, right? So up here, it would have been iterate through 1 through 4, because it won't include 5. So we're missing index 0 by doing that loop. So then down here, what is this saying? This is saying do 5 minus 1, which is 4. Are we just doing this the last index again? What happens to the 0th index? Why don't we do that? Well, we do I-1 in here, so really the I is for this, which is probably an original bug. So that's fascinating. We're actually doing 0 through 3 in this loop, but looking at the ith tile data map. And then down here, I guess we don't need that. Like, this if statement is completely missing when we're looking down here. So we clearly didn't need it for this final tile data set, which is interesting. I'm trying to figure out why that might be. So the only difference is that it's the last one, whatever significance that might have. Yeah, I'm just trying to understand, but it works, so I kind of want to leave it be. It would be nice to understand why, though. It's fascinating. But we can incorporate it the exact same way, right? There's no real difference in how we do this, so if we wanted to follow the same thing, we just copy over the index right here and go one step further with the else statement, like so. So that's not too bad. It's just interesting to me that we did that. I'm not going to worry about it right now. I want to make sure this works, and I also want to see if it results in faster speed. It should, because we're not constructing this string over and over anymore. So that would be great. Actually, we're not quite done here because we didn't actually insert the value into the map yet, did we? Also, this will always be the same, won't it? Like, we can always return the same value. I just have to... Yeah, I just have to write it first. It's like the if statement only says we have to write it to the map. So we haven't actually done the map writing part yet. So whatever we get out of the asset/maps plus base source directory, that needs to get stored inside the map. So I did forget that part, and first GID is local in there, so we need to pull that out, like so. And then in here we have to do the exact same thing. So it's gonna look like we're only gonna have one of these. In either case, we're pulling from the cache. It's just whether or not we have to populate it first. I went a little too far there. Okay, so instead of doing all this, we just need to set it. So it's gonna be cache file names i-1 equals this. Just like so. And then we have to do the same up here. One more time. Yeah. So, simplifying things a little bit here. But it's pretty typical when design code, like, your head kind of bounces around, right? Like, logically, you're gonna do one thing, and then you realize, oh, something else is happening. Then you change your logic around again, until it makes the most sense to you. So, this looks good now. Yeah, it's playing some Touhou songs. These are done by a company called Aquastyle, and they actually make the Genso Wanderer series. The Genso Wanderer series is like a Pokemon Mystery Dungeon flavored type of game, but it's a Touhou game. So they have their own orchestra and music design team, and they make those for their games. So that's where this soundtrack comes from. Why is that hard-coded? It was just chosen in order to indicate tiles that are on the upper layer. So that's why we modulus it, because tiles on the upper layer still refer to the same tile set. They're just... We use the tile ID to encode whether or not they are on the upper layer. Which is a questionable choice, I will admit, but that's just how we did it at the time. A lot of this is tech debt and old code, and we'll find that a lot in a project that is this old. I'm gonna go ahead and start the build process for this. We have a syntax error. Yes, we do. Just a missing semicolon. And then hopefully that will increase this function dramatically. So to summarize, we created a static unordered map inside this function. Static variables inside of a function are instantiated one time for this function, so no matter how many times getTileSheet is ran, it's going to use the same map over and over. Although that brings me to another problem, is this index is not going to be the same for every single map. This is only valid for a single map. So for each map, you can have a different combination of indices to base source directories. So So do we need to have a map inside of a map? one map to indicate what map it is, and the other to indicate the index. Although if it's an index, it could be a map of vectors, because the vectors can just store the base source directories in the same indices as these tile data indices. I kind of like that. Yes, but this technically doesn't work right now because when we change maps, we're going to use cached data from another map, which is definitely incorrect behavior. So I overlooked that. That's fine. I think the correct structure here is to use a map of maps. Map name is a string, and the data type it stores is a vector of base source directories, which with each vector mapping to the index of whatever index we're trying to reach in there. So let's try this. So the first change we have to make is this is going to be map now, and then this is going to be 0. So it's going to look more like this instead. And that way for each map we have a different cached version. So really we're just adding map to all these. Not a crazy significant change, but it will make it work correctly. At least in theory. Alright, I think I got them all. Up here it says this is invalid. Oh, I have to put map name here. That's not a type name. Okay, and then up here we have to count. So we have to look for map, and then we have to see... we could pre-allocate it. Let's see, we're gonna have to pre-allocate the vector to be the correct size with initialized blank data. Either blank data or we use optionals. I'm thinking optionals, but this is starting to look like STL hell now, right? But that is an idea. That way we know if it's created or not inside the vector, and we pre-allocate the size of the vector. Is that an okay approach? So we would do resize or reserves. No, reserve is not right. Reserve is used to extend the capacity. Is that right? Let me see. I think reserve is used to extend the capacity. I think if we want to initialize... Let's look it up real quick. Also, we're doing reserve on the map, not the vector. But yeah, let's look at standard vector reserve real quick. Standard vector reserve. I don't think that's right. I think there's an actual resize. I don't want C++, I want CPPRef. Increase the capacity of the vector without requiring, or excuse me, the number of elements a vector can hold without requiring reallocation, but it does not change the size of the vector, which is what I thought. I think what we really want is resize. Oh, that's wonderful. Standard vector resize. Here we go. Resizes the container to count elements. And naturally, if the container is too small, it will reallocate, which is expected. So we're going to do resize to a length of whatever we're interested in here, so it'll be tiledata.size. I think that's correct, because if tiledata.size is 1, it will use index 0. So naturally, the element will be of size 1. And if we have more than 1, then it'll allocate to the correct size as well. And here we're accessing the size -1th index, so we're never going out of range. So we should be good there. I think that's right. And then since these are optionals now, we have to do a little bit more work in terms of accessing them. Sure, we can assign them there, but we can't immediately access them like this. We have to actually pass in the value by dereferencing it. Well, it's not really dereferencing it, it's not a pointer, but in standard optional syntax, they provided that, so you can essentially use pointer syntax that you're familiar with for optionals, just as a free shortcut. Yeah, so that's nice. And then we're looking here, so now we're only concerned with if the map if the map already exists in the container. But even if it doesn't, we should make it. So we don't even need to check that, do we? We just need to check if this exists, which we're doing by doing if 0. And yes, this is valid optional syntax, so by default optionals initialize to empty, and so the boolean will return whether or not the object actually is not empty. So we can use that syntax now instead. Like I said, I think the optional, I've talked about this before, but I think the optional syntax is beautiful. I think they did a good job with making it very fluid to use. I really liked what they did with it. So there we go. This is now converted to use optionals. That way we can check if it exists already. That means it's reserved, so we can reach in from the cache. If it doesn't exist, we're adding it to the cache. But because these are already pre-allocated, we just have to insert new objects in them. We don't have to deal with any, like, push into a vector or anything. Essentially, they're fixed size arrays, but they're not fixed size. I think it would be nice to have a runtime error here as well. I'm just going to add one real quick. If at any point in time... Let's see, how do we add this, though? Because this will be a static unordered map. It will always exist. So what we could technically do is we can say if cached file names map dot size, so we're looking at the vector, ends up being greater than or equal to tiledata.size at any point in time, then we know something went wrong. Like we did something terrible, right? I like to add these in, these like runtime errors, because they make sure that if I've done something foolish, that it'll try to catch weird behavior. Like we should, because vectors can be easily resized or they might not be the right size. In fact, I would argue this should always be equal to. If it's not equal to, we've done something wrong. Tile data size is not equal to cache container, cache vector size. And we just put that is not equal to that. We'll use standard format here, and we'll add in both size values into the error string. So that's going to be cached file names map.size versus tiledata.size. Probably flip these two so they kind of match what the error is describing. Like so. Okay, and then what is it complaining about here? Oh, we have to dereference because it's an optional. And we should be good to go, maybe? I don't know, I'm seeing a lot of red. Did I miss one? I'll try a rebuild. We'll see what the compiler says. C, C++ game dev Toho. Coolness points are doubled. Yay! There's another syntax error. Whereabouts? Oh. I think we went crazy on the braces, did we? So that else... So this one shouldn't exist. This gets indented one... Wait, what? Why are we indented then? That ends there. So it looks more like this, which isn't right. I'm missing one. So that's the for loop. So that's supposed to be back. This one's missing one? Yes. Wait, no. If cached file names... If it doesn't exist, these should all be nots. I realize that's a logic error we made there. So those should be nots. And then... That's fine. That's fine. Okay. Looks good. So build succeeded. Okay, so I think we'll do the same thing. Let's just open this up and... So we fixed up one lambda. One lambda should be faster now. But we still have to do another one. Also, I think profiling is on right now. So I want to turn that off. Disable. Okay. Before it's too late. Ooh, an abort has been called. That's always fun. What is this? tile data size is not equal to cache vector size. 5 is not equal to 5. Well, 5 is definitely equal to 5, thank you. So I must have messed up the logic for that. Let me see. Oh, if they're equal, we produce an error. I'm just reversing all the logic. Okay. Well, at least we know the error works, but 5 is not equal to 5. Yeah. Today we learned. Okay. So it's reading everything in. Vector subscript out of range. Okay, that's fun. Let's see. Alright. What did we do? So, subscript out of range, the I is currently 1. So that can't be it. Cached file names, there's a size of 1, which is fine. We can see here, tiny overworld alltiles.tsx has been populated for a world map. So you can kind of see like the values are popping up now, which is nice. You can get an idea of what this actually entails, because if we go to world map here, we can see at the beginning we have our tile sets, and the first one is that Mini Fantasy Tiny Overworld All Tiles, so that would have been the first one loaded in. So world underscore map, that would have been cached, but what is it complaining about? So is it complaining about, because we're in a loop, tile data is 5, so it's about to go through all of them. And it was saying vector subscript out of range. Well, which vector subscript could have been? Because this definitely has 5 elements, and we're looking at the 0th element because I is 1. So it could have been that. Are there any other vectors in here I'm not aware about? Tile colors? Tile colors is a vector. Tile ID is 9552. First GID is 1. 1 minus 1 is 0. So that should have been tile ID 9552, which I presume exists. I don't think it doesn't. That would have come from map tile sets. Cached file names for this would have been tiny overworld all tiles. And then again, if we were to dissect this further, tile colors. Oh, there's only 8,137, so that's telling me we've decided to access something we shouldn't have yet. Okay. That's interesting. Tile ID is 9552. Let me see if I can find that in the map real quick. 9552. Well, I don't see 9552 in here, but that's being passed in from somewhere else. Maybe it's -1, so it could have been tile 9553, which is right here. And if that's the case, that's probably like the top of a tree or something. But, maybe this is a result of the unordered map? Alright, let me think. Well, not this unordered map, but, the unordered map that stores these guys. Because I'm trying to think here. If we're reading them, we should be reading them in order. Okay, if we were at this point, I think all these should have been read in already. And if they haven't, they would have been cached. So if the tile ID was 9552, then it should not have been the first one. So I think I'm missing something else from this reading function. When I originally made it, there's something else going on. So, oh, we had this if statement here. This is probably really important. If tile ID is less than the first GID, then we enter this loop. It looks like I just got rid of this if statement completely, not realizing that was a check to determine if it's even valid yet. So that makes sense. Okay, so we're gonna restore that line for sure, because that was a check required before we even entered here, to see if it was a valid tile ID for this tile set. So then we'll put and. Although, wasn't that checked somewhere else? Oh, it's right here. Back up a little bit. No, that must have been me copy pasting and doing weird stuff. Okay. Anyways, check that first. Check the cache file name. Go from there. We don't do anything if this is false. So I would even argue this is a continue. Let me see. That would be... So the reverse statement is a continue. So we can say if it's greater than or equal to this, continue. Because we're essentially looking for what tile set that tile ID falls under. If the first GID is too... The first GID of the next one is too low, so we're essentially saying, okay, look at 8,138. Is that 9,250 whatever larger? Yes? Okay, continue. Check this one. Doesn't fit in here either. Continue. Okay, now it fits in here. This is the correct tile set. So I think we're good there. We can continue in the loop if it's not that one. I'm happy with that. Yeah. This is why your code needs to be pretty well named and organized and clear, because when you come back to your code years later and you're trying to figure out what the heck it does and why it does it, this is what you have to deal with. You have to understand your code again, so the easier it is to understand, the less work you have to do for yourself. Saving your future troubled self. Alright, so I guess we have a successful level load, so that's good. I still want to profile what it looks like now. I don't immediately see like a difference in load speeds. Obviously the giant map we're about to load is going to be the big benchmark, but we'll see. Yeah. Let me again put a breakpoint at prepare level right there, and we'll take a look again. So it should have called, yes. Now I'm gonna enable CPU profiling, and then we'll go ahead and continue. I'll do this. That step was pretty early and gets called a lot, so I suspect that maybe we'll see some improvements in a couple spots here. At least I'm hoping. At least we'll be rid of the string constructions, which apparently was a lot of string constructions. That might also explain why the release build probably is a lot faster, is because it probably optimizes those string constructions out. Which is a good thing, but I still would like debugging to be faster too when loading a map, so that would be nice. I still remember the first professional coding job I worked, and seeing things being named with long descriptive names, it was a revelation. Yeah, my code used to be a lot of ABCs, IJKs, this var, just var, something, thing, calc, right? Like, you couldn't tell what the heck the function was doing. Anyway, let's see. Let's open details. Take a look again. Make sure we select the right call tree this time. Okay. So we're gonna look at... So lambdas 10, 6, and 4 are still the hotspots, which is expected. Still constructing basic strings being the hot stuff. That's surprising. But let me see. So a lot of calls here and here. So this has definitely gone down. This was the hottest point before. Now it's up here. Probably just because of the frequency of the calls. The S2I conversion from a string, I guess, is a bit expensive. 2 S2I conversions. Which I guess still results in a string construction, doesn't it? Because this string gets passed onto it, although I would assume it'd be, yeah, like, this string will get passed on there. I guess caching this next would be nice, right? Because the GID of this map never changes. In fact, I kind of wonder if there is a first GID value inside of there already. I want to say there might be. Like, it's a property of a map to know what your first GID is, although Get tile sheet. But it looks like this function is referenced pretty much everywhere, so optimizing this helps in a lot of cases. But I think we can actually cache this in a different location. Oh. So this is... I think this is an XML map. Like, it's going to be a vector of XML tags, and I think... No, it's a vector of XML tags in a map where we grab it via... grab the tag via a string. I think that's from data, but I think initially... Let me see. So my question is, can we get this to be stored one level out? Well, I guess we can't if it's an XML tag. If we create another tag type that is derived from it, maybe we could get away with that. But right now it's just a standard old map. Standard S2I faster? I think they're probably the same call. It's actually calling standard S2I already. Windows just kind of does that, or at least I think Windows is doing that. It's just like, okay, S2I just points to standard S2I. But yeah, caching this might be good. I kind of wish I could store it in here, but the way to store this would be modifying the map parser to read that in while parsing the tile data, which is not entirely impossible to do. It might be a good choice. And at the same time, I would probably grab the source as well. Although we still have to parse the source that way too, so... But I could cache it as well. That's not a bad idea. I'm thinking about it, because we do use it in multiple places, so that would be nice. So this would be like cached GIDs. And again, we'd have the same rules apply. The cache GIDs are based on tile data and based on maps. So again, we need an unordered map of map names with vectors of what look to be integers this time. And I guess they still have to be optionals because what we're doing is trying to figure out if they already exist, and if they do, we read from it, otherwise we create them in the first place. I mean, it's not a bad idea. It's just gonna make the code more verbose, which is pretty natural if we're trying to cache things. But it does make it pretty messy. Like, if I really want to do this right, I would actually go into the TMX parser here. And the first thing I would do is create a new type. So this is a header file. It has the header and the implementations in one file, so it's like a single header include kind of deal. Which means when we get to the implementation, it's all grayed out because they are currently inactive, which makes it hard to debug while typing, but I do have this commented out macro I can put here, which allow the code to include itself for a temporary amount of time until I'm done writing. So then at least I get IntelliSense hints, which is nice, but this is XML tag. I can derive from XML tag to add special characteristics to a tag I would like. So for example, we can see here, foreground tile tag adds one property. So in our case, we want to add two properties. We might as well read in the first GID and read in the source because we're assuming all tileset tags have this. And I guess that's what we're calling it. We're calling it a tileset tag. So first GID followed by a standard string of source. We could even take this one step further. If we already know that in our map, let me open up a different tab. So if we already know our use case, which is we're going to have to read in or parse like a base source directory, maybe we just include that functionality in this tag while we're at it and store that. Like, does the source actually matter, or does parsing the base source directory actually matter? Right? So maybe we can just do the parsing here, and essentially we've created the cache, but in a tileset tag for ourselves, and go from there. That would clean up a lot of this code because now we just have to access those and we don't have to store a temporary map. So this would be like the refined version of what we're trying to do now, noticing that we need to cache more than one value. I think this is the better approach. As for actually doing this, we need to find the tileset tag, which gets read somewhere. Here it is. So right now, we're just pushing that back into tileset data. We're now going to push back tileset tags instead. So we're going to change the type of tileset data to now be tileset tags. And then from there, we get to update this. So we're going to calculate the first GID. So new tag. I'm actually going to grab that real quick and just create that as a new constructed object. Tileset data, new tag. And I'm going to do an mplaceback. I don't necessarily need to copy it again here. So we're going to use mplaceback. And for new tag, we're going to say new tag. Well, firstly, we have the actual tag information, which already has been assigned and taken care of. We just have to populate more stuff. So new tag dot first GID, which should be in here. Apparently it's not. Oh, it's not tileset data, it's tileset tag. Got a little confused there. So, first GID. Refining data structures to improve the usage code source. The usage code sounds like a win, yes. Because once we're getting to a point where we're writing very complex code just to cache things, it's like, it's time to move that caching to what's actually responsible, or in a place that's more isolated, to make the whole code easier to understand and use in the future. So to read the first GID, we just do the same syntax. We're going to do data. At least it should contain the data. Oh, I have to do new tag.data. Data at. And we have a first GID tag. So that one's easy enough. And then we're going to do S2I here, which is fine. So it should look like that. No conversion from map to int. What? First GID. This isn't a map, is it? Oh, it is a map. But I'm doing S2I on it. That should be fine. I think, IntelliSense has to catch up. Okay. But that looks okay. And then we have the base source directory, which we're hard-coding as assets/maps plus everything from the leading slash onwards. So I'm basically going to just be moving that code. So we first retrieve the source value. And I guess we're going to do a little bit more work with this. Start with a standard string. Here, let me just grab these two actually. Okay, so this is our data. It's just whatever our new tag is. Grab those, and then insert into this. Base source directory is this, plus the base source directory. Done. We make these two const. Okay, and then we insert new tag in there, and we should be good. What's your tip to someone starting out CPP data structures? Yeah, I am reading chat, sorry. Just coding as well, of course. Tips for starting out with data structures. I don't think I've been asked this question before. Only because it's data structures specifically. If it was just C++, it's like, oh, I usually recommend like learn CPP. But when we're talking about data structures, it's like, it's a little harder because the answer you typically get would be something like, oh, you probably need to do a bunch of like problems that utilize these structures. Which is kind of true. Like, you can go on like a code problem solving website and do some problems to try and utilize these structures. Like, I think Advent of Code is a really great way to do that, because it also requires you to pick data structures that will optimize your results. But it gets kind of boring. So I guess my advice kind of falls under the same realm of somebody asking if they were going to study more C++, is just designing more projects that you might be interested in, because real world problems require you to really think about your data structures and how you organize them and solutions for them. Like right now, we're reorganizing our caching because we originally made a small data structure to do that, and now we're organizing it even more to try and improve the speed of our code, which I think is really what data structures and algorithms are all about. I think making games, especially code involving like pathfinding, when it comes to like real-time pathfinding, or even just real-time like movement of many entities, talking like millions, requires very well-designed structures. And that is actually a good way to learn data structures, in my opinion, if you're trying to do like real practical applications for it. What do I think of the job market right now? I'm not sure about the job market because I don't actually work professionally in programming, but the only thing I've heard was like a lot of rumors and chit-chat about companies that have been leaning either for or against like using AI technologies in their day-to-day development, and some companies are now shying away from it and bringing in more experienced developers again, while other companies are still trying to utilize them and cut down. And that's really all I know, and that's like kind of old news now. That's been around for quite a while, so I don't really know because I'm not actually in the job market. Let's see. So I just do this for fun. So I've never coded professionally. I've never worked on like a professional coding database. That's probably pretty clear by like my coding style and preferences. But I do know a lot. I just haven't actually worked on professional code bases before. I've done like a full stack web dev internship before, which was pretty enlightening and got me to learn a lot of modern web dev, so that's fun. I don't know if I like web dev, but it's good to learn new things. It could be helpful someday. Alright, so I'm getting rid of this cached file name structure. This is all going away now. We're now relying on this tileset tag to have our information for us, which is nice, because we don't have to do all this anymore. We just have to simply grab the information. The information should be inside of an array, so all we have to do now is say tiledata tiledata 0 dot base source directory. At least in theory, that's what we should have to do. I don't see it popped up though, so I'm not sure if that's a good or bad sign. It looks like it's not happening. Let me see. Tiledata. Oh, we have to change this now. This is now a vector of tileset tags, which should give us the correct result that we're looking for. And we now supply it here and here because we pre-calculated it at load time. At the map loading phase, which is at the very beginning of the game. And then we can do the same thing down here. We just put i-1. Oops. Yeah, we can delete. So now we can go back to a much more simpler code while also having cached data values. So now we kind of get the best of both worlds, which is nice and probably reduces a lot of overhead. At least I'm hoping so. And then we get to look at more stuff after this, I guess. This is tiledata.size -1. We don't even have to calculate first GID anymore, that's already cached. So that's also nice. Just have to put all these in the right places. First GID. Cool. And I think this looks a lot better than before. Oh, we don't have to calculate that anymore. This is now just first GID. It's a lookup. Yeah. And this is a lot cleaner than that nested standard map. I think I still include the -1 though. That would keep the logic in check. But yeah. I don't need the nested standard unordered map with the map name as the key and a standard vector, standard optional thing in there. I was getting a little over-engineered if I do say so myself. This is much, much simpler and cleaner to work with and understand. Just have to make sure I plug in the correct stuff. And all the data should be good there. Cool. So far, so good. Got some errors. No binary operator. Left shift. Let's take a look. Ah, okay. So we've changed the type here. Tileset tags do not have a left shift operator, which is fine. It's going to be the same thing as the XML tag left shift operator, I think. Well, we can make it more fancier. Let's do that real quick. So let's make a... Is this actually the vector? It is the vector. So we're doing a left shift on a vector tileset tag, which just iterates through all the elements and displays the tag, but then we're going to add a couple more pieces of information. This is just for debugging purposes, and we rarely ever bring it out, but it's a feature that is included, so we will do it. So take the left-hand side, and we're going to add in the tags. First GID. Or is it the right-hand side? No, hold on. So for each tag, okay, but we don't care about tags here, we just care about first GID from right-hand side. Or, no, because that's a vector still. Tileset tags. Tileset tags have the GID inside of them, so it has to go in here. So it'd be more like we have to append to this, and I guess we'll label it because we want to make sure we understand what we're looking at. So maybe it'll be like, yeah, tag can be unlabeled, but we'll put first GID colon first GID, and then we'll follow that up with... Oh, I missed one. Let's follow that up with one of these. Also, I'm just going to replace these while I'm here with standard end line. I think that's cleaner. It's entirely possible when I wrote this long ago, I didn't know what standard end line was. I'm pretty sure that's the case. Even though I've seen it many times in Hello World, I never thought to myself, oh, I should use that instead. I just think it looks a little cleaner, like more understood than a random /n there, even though it's shorter. Plus then we're respecting any changes to output if that gets done. Okay. So I like that. Yes, that is true. Although maybe a flush when we're doing this is not necessary, but that is a good point. Like, this technically wouldn't flush, which could be a bad thing if we're trying to print results, because sometimes it might not show up until later. It's like, I would want it at least at the very end here, like this. Or is that the beginning? I think the associativity is right to left, am I wrong? Oh, it is left to right. Okay, cool. I never thought of it that way. But at the end is best. I think I'm gonna start doing that. I actually like that even more, because it makes sense. You always want to flush at the end if you can. Okay. Although I think this is kind of funky because this assumes there's a... I guess there usually is an end line from the previous line, so that's why we're doing that. Okay. I like this row even more, so I'm gonna go with it for now. Oh, I have to remove the debug macro. Or my coding macro, I guess you can call it. Stop compile, please. It's very hard to stop the compile because it's multi-processor compiling. Please stop. Okay. Try it again. If this doesn't give me much speed savings, then I guess in the end we can start analyzing the entire loading process and saying, okay, what can we... How are we going to serialize this? Because essentially what we would have to do is write a program that takes every map file in the game and turns it into data that we would require when loading the game, which is mostly just stitching tiles together that are relevant. I'm not sure what else happens. I don't think much else happens, but definitely like these trees, they need to be stitched together. Looking for all those. I also believe tiles that are in the same row, like base row, gets stitched together as well, like horizontally, because they end up being one giant region that gets cut off at the same time. Okay, this looks like the already defined code from my define macro still being up. I just closed that, so maybe that's just old. Like it was using an old version of the header for some of these. Still failed, okay. Something's not right. These are also coming from menu animated icon button. That's interesting. Already defined. So we're getting already defined errors. So somehow I've messed up a macro. Trying to add these together when doing that. Already defined. Well, let's go take a look. Let's look at menu animated icon button. And see what it's doing. Maybe it's doing something funny. Because it is a header, so... Well, it includes menu icon button. Okay. And defines, but... I don't think defines has any problems, does it? Doesn't look like it. I don't know why a menu icon button would need tile set data. But it does include adventures in Listoria, so eventually we just end up back here, which includes everything. So... Are we thinking this gets included twice somehow? Maybe it's just a bug when I stopped, so I'm just gonna do a clean. And we'll just rebuild. Could be a bug with me stopping the compiling. That's happened once or twice before. Yeah, for something weird like this, I'm like, that's a nonsense error message. There's no way anything to do with something I haven't worked on for the last, like, year could be causing this, or is now a problem. Most of the time, there have been a few, like, defines. This happens especially when I try to cross-compile, like, on Linux. There'll be, like, a random define that only Linux defines, or it might rearrange the defines or includes. And when it rearranges the includes or defines in a certain way, then it causes more compile errors. Speaking of which, while we're waiting for this build, my latest Emscripten build from the very last time I streamed did not actually compile right, so I wanted to at least look at that real quick. So we'll go to our current working branch, or our current branch we're working on, and just review it. I just noticed it had an X, so I wanted to see why. Where's the error? Error called object type monster strategy is not a function. Ooh. Okay. Well, that's interesting. I'm surprised MSVC doesn't catch that. So apparently in Goblin Bow, we did not update one of the enums, so it just literally calls that instead. This is on line 325. Can we go there? 325 doesn't exist. Hello? Wrong file? Oh, Ghost of Pirate Captain. Ghost of Pirate Captain. Line 325. Yeah. I find this fascinating. It's probably just a, it's probably just like a compiler flag I can enable for MSVC, but this is an enum, by the way. So, according to MSVC, this is valid syntax. What we're supposed to do is now call, I think, run strategy. Because we changed this, like, we refactored this a couple days ago. So we use something different now. And just call that enum. So that's funny. Emscripten catches it though, so technically that boss stopped working. Let me see if any others popped up. Because maybe... Just says one error. I'm hoping that's the only one, but maybe more will pop up if they cascade. Also, the build succeeded, so let's try this again. My hope is that we do see at least some performance increase. That would be nice. In terms of loading a level in debug mode, or we just get an error because we did something wrong. Let's see here. Let me jump back one in the call tree. Okay, what do we got? First GID is 0. New tag data has a size of 0. Now why would that be? The tag says first GID is 0. Wait, what? New tag. This tag is completely blank. Is this what happens when... Wait. I'm confused. Alright, so what line is this? Where are we right now? What are we doing? Parse tag. Here's the line. It says tileset first GID equals 1, source equals map slash tile sheet no shadow 24 by 24 .tsx. Okay, let's see what file that's from. That is from file assets slash campaign slash 1_4. Just gonna take a peek real quick. Okay. So we were reading this line, and we got here, and for some reason, first GID, new tag. Oh, I didn't set the, I made a brand new tag that's just blank. We already have the new tag. I don't have to, well, what I have to do is actually copy the data from new tag to this local new tag. I don't think that's possible right now. I don't know, just copying a child class... I've never tried that before. I don't think it works, because that's fascinating. I don't think it works because they're not the same types, naturally. Like, I would have to manually copy over its members. I've never tried that before. Let's say we have a class A that has... This is my example testing project, by the way, that I just test random stuff in. And we have a B that inherits from A. And let's say A has 2 members. Number 1. I'm just gonna put 2 here, and number 2. I'm gonna put 3 there. And then let's say class B. I'm actually gonna make these structs so they're easier to manipulate. And let's just make a num3 here, call with the value 4 in it. So if I make an A and a B, can I copy... Okay, let's just say B.A is, or num1 is 0. I'm basically just saying these values so I can see if they copy over or not. And then I want to do B equals A. That doesn't work. At least according to IntelliSense, it does not work, because no operator matches. So I would have to write something to copy those over if I wanted it to work that way. Which is fair. Just an interesting experiment. Because I'm inheriting from it, so basically I'm gonna have to initialize this new tag with all the members of an XML tag with additional information. It's not much data, mind you. It's just tag and data. So I copy those two into new tags tag and data and go from there. In fact, I'm calling it the same name is a little confusing, but locally it's now referring to that one. So, oh, but now I can't refer to the old new tag, so I'm forced to change it. Let's refactor this real quick. Let's call it, what should we call it? Oh, I can't refactor inside of this block. Maybe I can now. Excellent. Tile set tag, I think is an appropriate name. And then tile set tag dot, yeah. So I would have to copy those two. Data equals new tag dot data, and then tileset tag dot tag equals new tag dot tag. And that should be all we have to do. Okay. IntelliSense is just catching up. We've changed quite a bit. I would say we haven't made too much progress on actual optimizing, but that's natural. We've basically just been scoping out the situation for today. I do want to look at a couple more code paths that we might be able to fix up, but it looks like at this point the speed increases we would get are marginal. So maybe it's time to write another program, just like a helper program for optimizing our in-game maps. So I need to start figuring out what that will look like. I will commit what we have for today though. We still got quite a bit of coding time, so we're gonna figure out a plan for serializing this data. I'd imagine it's gonna go something like write down what each tile set will be. Let's think about that. Each tile in the map has an ID, so it's gonna be an index into an array, or a vector in this case. And so it'd be very easy for us to be like, okay, object 1 consists of this tile, this tile, this tile, this tile, and just iterate, right? And then object 2 would be this tile, this tile, this tile, this tile, blah, 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 blah. And then when we're loading the game, all we have to do is say, okay, load object 0, grab information for these tiles. This is all object 0. This is all object 1. This is all object 2. And then same for the foreground and background groups. We say, okay, these two tiles are in the same row, or these objects are in the same row. So object like 2 and object 3 are in group 0. Object like 20 and object 21 are in group 1, etc. I think that's the basics of what we need to do there, because the brunt of the actual loading process is it has to iterate through this entire map to find all of these, right? That's why it takes so long. So once we have all of what we actually need to process, it'll load much faster. So we can already tell just from listening to that process that this is going to solve a lot of speed issues. Oh, I didn't even notice. I'm sorry. Tiger, you subscribed. I appreciate that. Thank you. I appreciate the support. Okay, so we're back here now. Let's see what's going on. Tile ID is 712. What was the error? The error was, I think we're just out of range again. Oh, this looks like a dead data value. Oh, that doesn't. I don't like what's about to happen here. Oh wait, this is trying to get it. Okay, so that should be junk data right now. This should be not junk data. That looks okay. I like the way you describe your process. It sounds a lot like my internal monologue. That's good. Yeah, I got used to just speaking what was on my mind because I think it's really important for others to understand, like, if you're programming, you're gonna go through a lot of these, like, thinking processes and trying to figure out what you want to do. I've also heard that when it comes to programming interviews, a lot of folks want to actually hear how you go about your problem solving, because that tells them, oh, you're actually, like, thinking about this, you actually understand what you're trying to do, you're trying to figure this problem out, you're thinking about all the possibilities, you're thinking about the advantages and disadvantages of the solution you're trying to implement, etc., right? You're basically speaking out, okay, here's what I'm thinking, and here's why I want to or don't want to do whatever I'm trying to do. I think a lot of programming isn't actually typing out the code, but you trying to do the problem solving. I think the problem solving aspect is the most fascinating part of computer programming. It's like a giant puzzle. You have a lot of different solutions at your fingertips. How are you going to use the knowledge you know to implement a solution that is required. And I want others to know that this is pretty much how programming works. You're not going to be sitting here like, oh, an expert programmer is just typing away. No, you're always trying to think and come up with solutions. Sure, there will be times where you're like, okay, it's time to implement something. You can get deep down the roots of typing out all this code, and we were doing that a little earlier, but then you get back to it and you're like, oh, I'm back to just reading code and debugging. I have a literal rubber duck here I sometimes explain out loud to. Exactly. Having a little rubber duck. It's like, oh, if I just tell it my problems, sometimes I get the solution from just speaking out loud. I'm like, wait, this is dumb. Or, oh, I just literally said what I meant to, what the solution was. This all makes sense now. So I is 2, which means it's going to be looking at this one, which is index 1. I still... Hold on. I need to know what was the error, please. And I pressed spacebar by accident. The error was vector subscript out of range. Okay. I needed that context. I'm like, what am I doing? Alright, we're probably out of range on tile colors again, is my guess. This is tile ID 712, which... If I read the tile data right, 712 is in the first set, not the second tile set. So did I mess this up? Okay, if it's greater than or equal to, we continue. If we did, we return. So we should have returned already if the tile ID was 712. What happened here? So what I is currently 2, so it skipped 1, but let's pretend it was 1 for a second. This would have been 0. Tile data 0 reads first GID of 1. 1 or 712 is greater than or equal to 1, so it continues. So that's not... Wait, wasn't this an I before? Oh, I must have done that by mistake. That was definitely an I before. I remember that because we were trying to figure out, like, why is it an I? Okay. Oops. I think that was just me hastily trying to remove all the code because I was like, yay, we're removing code. Oh man. Okay. Anyway. Yeah, this function has been modified like 10 times today. Fun. Okay, let's try that again. Get through our map loading. Yeah, I just genuinely enjoy computer programming. It's fun. Making this game has been fun. It doesn't really matter how long it takes, or if we accomplish what we were supposed to today, or like if we ran into a frustrating bug and didn't make any progress on what we were supposed to do. Like, to me, this is all just, this is how programming is and how it's always going to be. Ooh, we're at the breakpoint. Excellent. I'm gonna skip this one though, and we are going to try to load our giant level again. Okay. I'm gonna go ahead and do a diagnostic. Apparently it's been recording this whole time again, dang it. Let's just do another one. Okay, continue. It is fun. Even if you make no progress with the project, you end up learning something. Exactly. You really do. You really do. And that's really all it is. Like, a lot of folks always ask me, like, oh, how'd you get so good at it? What do you do to study and learn it? And I'm like, you kind of just have to bash your head against the wall every single day. I did put a breakpoint at the end of this, but I will... That's probably gonna mess with the results, I'll be honest, but we can try to figure it out. Let me see. I guess... Yeah, this is kind of a bad one. Let me just... Let's leave, and then let's put our breakpoint at... Where's loading screen? Right here. I deleted that by accident. Okay. Turn to map. And... Yep. Do that. Do that. Record. And continue. One more time. What's funny is I think I could have sworn I originally wrote code that was... Oh, it's right here. or something like that. It's like if the previous level was equal to the level we're loading, we don't have to do all this again because it's already still there. But I think if we return to the map, that's another level, so it ruins that. Okay, so we're done there. Stop. And I will look one more time at the details. I felt a very small increase, in my opinion, of loading time. I don't think it was much, and that's about what we expect. But still, improving that optimization was nice. And I'm going to suspect that something else is more holding up the loading screen now compared to before. So we'll see. Oh, Lambda 6 has taken the lead now, instead of 10. So probably something a little different. Now we're getting hot stuff in get current map data. So we're looking down here where get current map data gets hit a lot. In fact, it gets 3 calls in here. Well, every iteration loop. Also right here we have an equal range, which this is a multi-map. So that's fun. Yeah. The fact I use a multi-hash map here kind of scares me because I'm gonna have to dissect that if I want to optimize that later. So that's gonna be interesting and fun. But it is part of our slowdown, which I think makes sense. Multi-hash maps start getting a little slow because it's essentially just you have to look up multiple things for the same key. So you're essentially doing like search through a vector inside of a map, which is a hash plus however many elements are in it. And these are tiles, so there can be quite a few elements in it at once. You have to iterate through all of them. Yeah. So it makes sense why this would be the next real big hit. The other lambdas still have a little bit, but they've significantly gone down. So in terms of all this being relative to each other speed-wise, we've definitely sped it up a bit. Get tile sheets still is one of the most expensive things, which makes sense. It's just not as much anymore. It's just there's so many tiles. So like I said, the best thing to do now is to start offloading this to a pre-loading program, which is essentially what we're going to do next. So the first thing I'm going to do is commit everything, and then I think we're going to push all this into a new branch because we're no longer dealing with skeleton fire mages. In fact, I might just bring all these new changes over now. I'm going to unstage this. I'm only going to stage the Ghost of Pirate Captain, which was a bug fix. Fix enum fake function call to use run strategy. Use new run strategy function. That's the only fix I want to make in this branch right now. Only because I want to make sure the Unscripted build actually builds. I guess I'll bring over version 2, that's fine. So that is release build 12571. Okay. Just commit those. And then I'm going to sync that. I'm going to bring the rest of these changes over to a new branch. So we're going to do new branch based on Skeleton Fire Mage. We're calling it map preloader, I think is what I'm going to call this. Now, does the map preloader even want to be in this project is the next question. It's like, okay, the map preloader branch is all the code that supports all the map preloader stuff we do. It's not necessarily the preloader itself. So for now, this is like minor test optimizations for reading it, first GID and source tile set file names. At least that's a good description for it. So this is the map preloader branch, and once we make the map preloader project, we will have whatever it outputs be read into the loading screen functions, the loading functions. So let's start a new Visual Studio project. Just a C++ project that's going to accept a file input and do some stuff with whatever it reads. It's actually going to accept a T... Well, it's going to be in the same... So if I'm thinking file structure-wise, I want to put it in the same place as Adventures in Lestoria. The only thing I'm worried about is I don't want to put it in with the source files because it might think those source files are for it. So it definitely needs a new folder in here, at least in the Git branch or the Git folder. So let's do, well, we'll do create a new project. We'll do empty project, C++, and then let's just make sure we define this right. So the repo is Adventures in Lestoria. That will make it be, yep, that's what we want. So this is the map preloader. And I think what we'll do is eventually we'll write a script. See, these are just extra features for later. Maybe we can like hash the file, the map file, or we can look at the data as modified. We can keep a list of when the maps were modified. If there are changes, like we can literally run this program on build, and if there are changes, it will rebuild them. So essentially we're making like a program that will rebuild maps when they change, which I think would be kind of fun. Okay, so let's get started. Let's just start where we always start, with the main.cpp. Go from there. What do we have to do first? Let's load in some files. So I'm going to grab an fstream, and I'm going to grab, I guess just for some debugging, let's grab an IO stream. We want to accept arguments. So int main, I guess we'll just accept the standard good old, I don't actually know if this works. I don't think it does. I think you get a char star out of this. Char star args and I know you get like a number. I don't know if it's an int. It might be an int. Arg count or something. I'm just gonna try that real quick and see what happens. I'm a little fuzzy on it, but let's just do arg0 and arg count. I just want to see, actually we have print now. I really like to use print instead, it's just better to type. But we do have to switch to C++ 20, I think. So let's try include print. I like that a lot better. Let's just do standard print line. We'll do 1 space 2 arg0 arg count. Cool. So I'm going to build that, and then I'm going to run that program with an test argument real quick. I'm starting to use it, but I keep finding things that only want to work with cout. Oh yeah, there's gonna be plenty of that. Cout has been around for forever, so everything supports that, or initially supported that. Yeah, making things work with the new print, you have to add your own custom things a lot of the time, which can be a pain. Alright, my executable is in here, so I have to get there. Map preloader .exe. Let me just try test! Exclamation point. Actually, I think argument 0 is supposed to be the file name anyway. I have to do /. Okay, it didn't output anything. That tells me these probably aren't right. So let's int main bpp main function int, oh, they're backwards. It's int argc char star argv. Okay. I'm surprised it just lets me build with whatever I want in there. I think I found that out one day. I'm just like, can I literally put anything in here? And it kind of worked. Hello? Oh, it died. Okay. I was like, you wrote bad code, so we're restarting now. Build? It probably just assumes an int main with nothing in it if you don't put the right stuff in it. Okay, so now it outputs space 2. Arg0 is nothing. That could be because we're already in this directory. No, it would probably show the directory, or at least it would show map preloader.exe. args1? I don't know what arg0 would be then. If it's not that. Oh, now I get a weird character. Okay. Well, it's a char star pointer, so... Interesting. argv... The parameters of the two-parameter form allow arbitrary multi-byte character strings to be passed. argv index. Standard quoted argv index. That's interesting. Is the first argv always the name of the program? I assume so. According to the example, it is. This is weird though. I didn't get what this... Oh, yeah. It's a pointer to an array. That's what I missed. Or it's an array of... So it's an array of char stars? Does that mean... Array of char stars? Yes, an array of strings. That's correct. That would make more sense. I was literally pulling like... I was literally just pointing the pointer to the pointers, I guess. There we go. So it outputs test space 2. I assumed if I outputted arg0, it would give me map preloader.exe. And it does. And well, it gives me the full file path. Cool. Anyway, that's how we grab arguments. So we're expecting 2 arguments. So let's do... If arg count is 2, is not equal to... Wait, no. Are we expecting 2 arguments? Really, this is going to be a function that just accepts file stuff and it goes from there. I think what we're going to start with is we're going to say, okay, where's the directory of maps? So we're going to expect to go into campaigns. So we're just going to say, let's grab a file system and we'll do standard file system. I don't even really need file system, really. I just need a string. So maybe we won't do that for now. Standard string main path or base path, either way. I'm just gonna make it relative, so we'll jump back one. It'll be // into campaigns, and then from main path we can start grabbing our files. So we'll iterate. Oh, we do need file system because we're gonna iterate through that directory. That's why I needed that. So standard file system. Oh, path. Is that right? Is it in file system? I think it's in file system. Path. There we go. Path, main path. And then from there, oops. We can go ahead and say, all right, so we're iterating through those. We get, I think we just get strings, or we get another file system path out of it. I'm not exactly sure. But let's do file in path. This is a path object called path. Yeah, I don't think it returns strings, but it returns something similar. Cannot be initialized with value of type const file system path. Non-const qualified. Const. And no conversion. Okay, yeah, it is a path, so I guess that's expected. So whatever file we get out there, let's just output it for now and go from there. File. Let's make sure we're actually getting useful contents out of here. Okay. That is not... Oh, we have errors. Parse is not a member of... Oh, there you go. There's your first example. Parse does not exist for a standard file system. I can convert it to a string though, of course. But I'm like, there's your first example of we can't use println yet. Alright. That's not the folder I was expecting. What is this folder? This is... Adventures in Lestoria, Assets, Campaigns... Wait. Is it listing... Oh, it's iterating through all the... Adventures in Lestoria, Assets... Anyways, I feel like this is redundant. This should just be in here anyway. But That doesn't look right. Or at least I'm not understanding why it did that. It's outputting like each folder, which is not what I was expecting. I am calling print line, so print line is saying, okay, for each of these, it's like blocked it up. I guess I need to call like, path, relative path, root path. I don't think that's what I want. Let's take a look at how we do this. Standard file system path. Okay. It says the path name has the following syntax. Well, let's just go to constructor. Path. So, number 4 constructs the path from a character sequence provided by source, which is a pointer or an input iterator to a null term. Also, it's a format interpreted. That's actually kind of cool. I actually really like that. So if it is a directory, it will appear as such. I think me iterating through them is the wrong move. I think it's iterating through like each folder going in. I think that's how it's stored. Like, it's an array of like each folder. I was talking about earlier, it's like a hierarchy, right? I was just expecting when I used it to return what's inside of it, but really I have to grab what's actually in there. So, so let's see. How do we iterate through a standard file system path? The path can be traversed element-wise via iterators returned by begin and end functions, which views the path in generic format and iterates over root name, root directory, and the subsequent file name elements. Okay. That doesn't really help. File system library. File system exists. File system absolute. Okay. Well, let's see here. Standard file system. Iterate over directory. For const auto dir entry recursive directory iterator. Oh, okay. Standard file system recursive directory iterator. Standard recursive. Does that not exist? Oh, it's file system recursive directory iterator of path. Let's take a look at that one. And we got an abort. That's wonderful. Oh, it did it there. Wait. I hit build. Why does it not work here? Oh, it's relative, and I'm inside some weird directory right now, that's why. The assumption is I'm gonna be running it from... Yeah, so is the assumption being that this is where the executable will be dumped now? I don't know. I gotta think about that. Because I could just have it dumped into a different location and that would fix that, or I could keep it relative. It would be a lot of ... 1, 2, 3. I have to go back 3 folders. 1, 2, 3. Because when I run it here, it's relative to the actual main directory of the project, but when I run in here standalone, then yeah, I get this. So that iterates through all folders. So now I gotta decide, do I want it to be easy to run in debug or not? Or I just make the working directory always be correct. So I think I'm gonna this is one of the times where I think the working directory being the different is going to bite me in the butt. So we're gonna go to our directories. We're gonna go to executable directories, and I'm just going to change this. Oh, not this. Advanced. Where is it? It's somewhere in here. I just gotta find it now. Maybe linker, because it's a linker thing. Let me see. It's either gonna be like linker or output or something. Output files? Assembler output, no. Object file name, module output file name. Do we have a working directory, maybe? Dang, I gotta find this. See, debugging uses working directory, so we could change that. Let's just change that. I think that would be best. So instead of project dir, we're gonna do let me see if I can find the macro for this. It's like we're looking for like the executable directory. Executable. No, that's not it. Let me look for like debug. That's the recipe. That's close to what we need. Int-dir full path. That's almost what we want. Oh, here it is. The local debugger command. I feel like that doesn't quite describe what we want, but it does have the right... Oh, here we go. Target path. Okay. So I'm just gonna use that one in case we change it in the future. But target path does sound correct. So we're gonna use that for debugging instead. And I'm going to apply it to all configurations actually. In case we do something with release build, it'll be the same. What to assume about working directory? I think I would end up with a config about directory locations, which you can set during install. That is true. Right now this program doesn't have any config, so unable to start program. Is this just not referring to the right place? J, Adventures in Astoria, map preloader, x64, debug, map preloader.exe. It is there. Not a val- oh, .exe is not valid working- I forgot. We're supposed to specify the working directory, not the executable, so that's not target path. It's probably like target dir. Let me try target dir. There we go. That's what I want. Okay. Alright, that's good. That's what we want. So now we get the same results if we run it from our local location or we run it through the debugger. So yeah. Now that we've done that, the next thing to do is we're going to iterate through all the files. So, and then we're going to do some kind of like parse, not really parse, more like optimize or generate preload. Oh, that's Korean again. Generate preload file for each file, and then we start from there. So I'm just separating it now because I'm pretty sure like eventually I might make a generator class or something, so this might be a good opportunity to separate all those things, but for now it's just passing in the string. Now the question is, do I want to pass it as a string view? I don't think I'm going to do that. I'm not messing with string view stuff anymore. I've learned my lesson the hard way. I'm never doing that again. Okay, so what do? We gotta figure out what to do, right? So we gotta go back to our actual game, and we're gonna start with, what do we do in loading phase? So that's internal to the game. Monster spawn data setup. So this gets information about all the spawns in the game. It's a very small amount. This isn't gonna affect performance at all. And then we have identify upper foreground tiles. So this iterates through, it looks like zones, which there aren't many of, by the way. So I'm not worried about the zones either, if that's all this does. It looks like it will iterate through layers. It'll do x equals zone x, y equals zone y, plus zone width and zone height. So to me, it looks like, yeah, it's going to iterate through every tile in those zones and grab information about them. So we don't care too much about that. I think what we need to do first is we need to get the same information that our game does when we start, which means we need the TMX parser and the TSX parser. Now this is interesting because if I ever change these in one project, the other project should have the correct versions of these as well. So I wonder if I'm actually going to include these headers via a whole nother location and specify that as the source. But I have to be careful about that because I need to make sure I don't accidentally include stuff I don't need. I just want to make sure I don't want to have outdated files. god, that was a mess. I don't want to do that again. I'm good. In 6 months, we can mess with string view again and go through it again. We always do. But right now, I'm good. And okay. So yeah, I think that's what we're going to do. We're going to literally just grab the TMX and TSX parser from my current project I'm working on and grab them in here. But if I just try to include them as is, it's not actually going to recognize them because that's not a valid source directory for files. So like I can try, but it's just not going to appear in my includes yet because I need to include those as a source directory. So let me go in here, go to directories, and we need to do, I believe, source directories. Had to use when searching for source files. I don't know if that's right or if I need, I think we need include directories. Yes. So we're just gonna do ... I tried to keep them relative from projector. So we need the, I believe it's just projector. I'm gonna pull up macros actually, just to be safe. Okay, let's try this. New money sign projector. So that resolves in what? Not even do anything? Okay. So we have to back up one. So slash ... slash adventures in Listoria. Okay. Slash, I believe, oh, maybe I can click this. Well, I know I'm gonna have to prepend this, but I think I can use this to get pretty close to where I want to be. Oh, it's literally just one more directory in. So if I back out one, we're in, I guess I wasn't supposed to type that extra slash. So backing out one puts us back to Adventures in Listoria, slash Adventures in Listoria. Perfect. Also, there's a space. Spaces. So, yes. Also, the lowercase I, that always gets me too. And we'll include that as an include directory. So now, we should be able to include TSX parser. At least that's my hope. IntelliSense doesn't pick it up, so maybe not. Oh. Can I open source file? Okay, maybe it is a source file. Yeah, I guess this is like the biggest gripe for a lot of people when it comes to the Solution Explorer, is that what you see here is not like a file directory, like a working file directory. So you have to think of it as more like, these are the files I care about and I'm going to include them here. And you can kind of get Visual Studio to say, oh, these are files of interest, but in reality, they can be wherever you want. Okay, I'm gonna try this one now. Source, maybe? Still cannot open source file, okay. Well, we're getting closer. We're on the right track, just have to figure out exactly which track. Okay. Or maybe I'm just specifying the wrong directory, let's see, because it was... Well, I kind of confirmed that it's... J drive Adventures in Listoria slash map preloader. Adventures in Listoria slash map preloader slash ... slash adventure. Aww. Oh, the typo got us. No. Okay, so I was probably right the first time then. But there was a typo, so I'm pretty sure that was the original issue. So one more time. Include directories, please. And there we go. So this is technically a header file linking from my actual project that I'm just including in here. So if I ever change that, it will be updated in here. Technically that's what libraries, compiled libraries or static files are for, but yeah. Ooh, we need FT2 build? Really? Why do we need TTF inside of TSX parser? That doesn't make sense. What? Oh, this includes other wait, hold on. That doesn't make sense. We shouldn't have to rely on TTF. Something is weird here. Come on, show yourself. Is it error.h? No. Okay. Let me see what the error wants from it. Oh, OLC PegX TTF. Well, why is that being referenced though? Like, what is using this file in this project? Because otherwise it should not be popping up. In theory. I could be wrong, but I'm pretty sure. Error, okay. TSX parser requires TMX parser. Okay, this is where it gets weird. Okay. Does OLC Pixel Game Engine require it? Is that where we're... Okay. No. Geometry Pixel Test Defines. I didn't realize it required this many includes. I thought it was more standalone, but it looks like it wasn't. So we might have to fix that first, if we want to use it this way. Otherwise we're going to have to copy-paste. Item.h. Oh my god, we're just entering my game at this point, so this is probably why. Eventually we're going to run into that font file, I'm sure of it. But let's see, I guess I'm searching now for OLC PegX TTF in here. So let's do a search in project for include. We're gonna look for all of them. OLC PegX _ TTF. I think that's fine. Alright. So it's needed in Adventures... Oh wait, that's a CPP file. It is needed in OLC Pixel Game Engine if we're initializing it, so that's interesting. It's needed in visualnovel.h. Okay. That makes sense. It renders fonts. It's needed in PGE PegX viewport. Okay, here's what I'm gonna do. I'm gonna try this first. Because this looks like a rabbit hole I don't want to go down. I think what we want to do is I'm gonna get rid of that source directory, and I'm just gonna copy paste TSX parser, and we're gonna try to make it standalone. Because I think that'll be easier to figure out, okay, why do we need all this junk, right? In theory, these are supposed to be very standalone things. I feel like the only real dependency I initially included was the error lines, the debugging error lines. So copy paste this and copy paste TSX parser, and let's start from there. Too many windows. So I'm going to... Oh, what is happening? Okay, don't... This is where we have to be careful, because that isn't the TMX parser. We literally edited the same file. So I'm actually gonna remove them, but that doesn't mean I delete them. They're removed from that list, and I'm gonna say, okay, let's make our own local TMX parser and our own TSX parser. When you do add items via the Solution Explorer, they automatically get placed in your solutions directory by default. So these are local to our project right now. That's TSX parser, and then TMX parser. And then we can start cleaning up a lot of the junk. Now, I do have another project where I have used the TMX parser before, but I technically want to use the same copy as I have for my game because we can get the same information. It's just we have all these extra includes, and I'm not exactly sure why or even if these matter. So we're about to find out, I guess. So these dependencies, I'm gonna say that realistically none of these should be required, but I know we do some special stuff with like VF2D probably, so there's probably that. And reading in monster data, I guess makes sense. I don't know to what extent we should emulate the game. Like, realistically, we only care about stuff related to maps and the map tiles. So what we should be doing is only reading in map tile stuff, which means it's starting to tell me we just need a generic version of this to do this. So I think that's what we're going to do. In one of my repos, I do have the original versions of these that I wrote that is just very generalized, right? It's just supposed to read a TMX file, done. I don't think there's anything special about it. Let me see. tmxparser.h. That includes our Pixel Game Engine and String Stream. I assume Pixel Game Engine is for like VF2D or something. No, not even that. That's surprising. What does it need it for? But yes, maybe we go back to this. It might be all we need, I'll be completely honest. And we can build it up from there. I don't know what it needs from Pixel Game Engine. I'm just gonna assume I don't need it. So let's... It does say using namespace OLC. Let's try it. Okay, so... I'm gonna get rid of that, assuming we don't need it. So we need map. I guess Pixel Game Engine originally included map. And I would even argue we only need unordered map, and we don't need Korean. Unordered map. Oh. Yeah. Okay. And then... I'm gonna change these to unordered maps. Technically they're a little faster, so I might as well. Yeah, this looks a lot simpler, don't it? We also need IO stream. Alright, what else? We need F-stream. I think we only need input file stream, we don't need output. So we'll do IF stream. What is this? Oh, we do need output file stream. Why are we outputting? Wait, this is F to data. Okay, that should be input file stream. That's up here. Incomplete type. Did I mess up? Can I open source file IF stream? Is it just F stream? Really? I thought there was an IF stream. For some reason. Okay. Anyway. TMX parser looks good. TSX parser? Oh. Why don't I have a TSX parser? Why only TMX parser? That's weird. How would it get the texture data? Is it because that we're assuming it's like a built-in map? Let me see. Like we encoded the tile set into here? Because you can do that, but... Let me see. And if so... Layer ID... Okay, well, no. Tile sheet, tile set. Okay, so the TSX parser was made in an attempt to actually do something with this, so they should be like hand in hand with each other. So I guess the TSX parser didn't exist at this time when I originally made this thing 4 years ago, which I guess is fine. Also, I will be right back, and then I guess we'll load up the TSX parser, which hopefully has less dependencies, and maybe I can make a project out of it, who knows. Alrighty, so... Yeah, apparently TSX didn't exist at this time, and this was a very crude version of the TMX parser just to get, I guess, the raw tags at the very least. Like the tile data, and that's pretty much it, which I guess is fair and probably all I really need, to be honest. Everything else can be obtained via the TSX data, and then we work from there. Like, as long as we have both, we're pretty much set. So let me pull from TSX parser and see what dependencies it has. Actually, I think we already did that, didn't we? Let's see what we can remove. In theory, there shouldn't be much. Sure, we can include the TMX parser, that's fine. I don't think any of these matter. Like, okay, so we have, like, foreground tile tag. I assume some of these belong to map.h, which might be the only relevant header we would want. And that was probably made to get rid of some conflicts with, like, including other headers. Yeah, we can see we have, like, a tile group, tile render data, tile sheet data, tile set data. If we just set all these up to read everything the same way, I think we'll be okay in terms of making it work. But at the same time, it's like, okay, so how do we know we've done the same things as before, right? Like, we're essentially having to reconstruct everything from scratch, which is going to be the hard part of this project, is like making sure it's still functioning the way we would expect afterwards. Why do we need Geometry 2D? Do we need Geometry 2D? Well, there is VF2Ds here. I guess that's just the choice I made. That's fine, because Geometry 2D doesn't require anything else other than error, which is something I added. I'm actually not going to pull that one. Instead, I'm going to pull the latest OLC util Geometry 2D from the repo, because the repo has a more up-to-date version, and I might as well use that one if I'm going to quote-unquote start from scratch-ish. Okay, so I'm going to include that. We'll see util geometry2d.h. Okay, just a little more recent, and I won't have to include error.h. That's like my own custom addition. I won't need SafeMap, at least I shouldn't use SafeMap here, so there's no reason to, really. So we should be able to get rid of that and replace SafeMap with whatever. And then I assume I need to do using OLC utils, because it looks like I start from Geometry 2D, so I need to include that using. Might go a little further. Namespace name is not allowed. Is it Geom 2D? So it might just be using OLC. Wait, no, that's not right. Are we not C++ 23? Or at least C++ 17 or higher? Oh, we're probably not, huh? I wonder if I undid that by accident. I thought we had print, though. Something's not right. What is this in? OC... Okay. That has the V2D stuff. Is it really just OLC? What about Geom? There it is. It's OLC : utils : geometry 2D. Okay. I mean, that would mean I would have to do utils. Well, see, this still doesn't want to work. Namespace qualified name is required, a namespace name is not allowed, and also namespace name is not allowed. Using? Oh, I don't think I mean to use using, I think I mean to use using namespace. Duh, okay. Renderable tile set. We don't necessarily need that, that's just the image itself. Foreground tile tag. Okay, so everything that map.h has, I presume I just want up here again. So I'm gonna bring that back in by copy pasting. Let's take a look. Don't need safe map. Don't need renderable. Wait, did I just do this like 3 times? Hold on. Something's not right. I think I just copy... Okay. So what is TSX parser then? Because that's completely different from TSX parser. Hello? Okay. Grab that and put it at the bottom. Okay. So now we should have everything. Foreground tile tag. Where did this come from? And what is it? Now we begin the fun part. Oh. As whether or not we hide. This isn't TMX parser, so we included TMX parser. Oh, so we have to include like new stuff. So we have like tileset tag, foreground tag, which we just made, of course, so I guess those are important. Safe map we replace with, let's just do I even need, I'll just do an ordered map here. I don't think I need organized maps for anything really. Let's see. We're also using namespace OLC. VI2D, Pixel. Pixel is from the Pixel game engine. I don't know why I need them to be pixels. Tile colors. Tile columns? Why are they pixels? That's the real question. I remember seeing them when we were working on code earlier. Loading code. They were under, here somewhere. Tile colors. And this is for tile sheet data. Tile sheet data. The tile color. Is it possible we can change the tile color? I guess? That's interesting. I don't think I've seen that used anywhere. I must have included that as a niche thing. I think I did it when I was making like a bonus level, and I'm like, I want everything to be red. So I guess that's what I did, but let me see if the parser does anything with tile color. I don't think so. TMX parser? Probably not. Yeah, that's interesting. And I just want to check all references to it real quick. And we're starting to dig into code that is very old, so a lot of this is going to pop up and really mess with things. Return data.color tile color in get tile color. And where is that called? I didn't even know this existed, or this capability was possible. So tile color gets set to get tile color, which again, map data. Let's see. Return blank. Return data.tile color if unlock is unlocked. Unlock condition. Figure out if any tile at this position is terrain. Okay. Return it from tile sheet data. Return blank, return blank. Oh, you know what this is for? This is for those, like, there's one boss in the game that actually modifies all the tiles to different colors as like an effect of its attack. So that's actually what this is for. So basically we just modify the tile colors directly and then return them. It's essentially a property of like every tile that just exists. So this has nothing to do with map reading or loading. I'm like, did I really support like tile tinting? That's kind of weird. I don't remember ever having that functionality, so I'm just removing it. It's not required at all. Keep adjusting these maps. Although it being the only ordered map in this giant list has me a little worried. Although I will also say that we didn't have safe and ordered map for the longest time. I never made it, so there's also that. Alright, what's going on here? Anything weird? String stream? I thought that came from TMX parser. Let's add a stream. What else? We have a bunch of log stuff, so I'm gonna remove those. We have a get string. Okay, so this is tileset class is terrain based on if it's equal to terrain. I don't think if is terrain matters here. If it does, we can add it back in later. I don't think it matters though. Pixel, we don't need tile colors, we determined. I don't know why this is required. And tile color goes away. Don't need tile color. Slowly breaking everything down. Okay. Honestly, if I have something like this, I should probably just throw so I know something bad happened. I can even go as far as to use a new standard runtime error and at least do that for the sake of understanding what is happening. This is about animation data, so that doesn't matter. This is... See, all these get stuff we had before, or we have now, wasn't there before, so they're like convenience functions for us. I would like to re-emulate them real quick. That should be easy enough. Just add back in like get float, get integer, get double, get bool, get string. That sounds pretty harmless. It won't do anything terrible. Oh, they already exist in XML tag. I guess they just don't exist in TSX parser. So we could add those real quick. There's also no get... Oh, I see. There's no get, what is it? get float. There's get double. But we need get float and we need to get string. Which I don't really know why we have get string because that's just direct, but yeah. Okay. So that implements the get floats. Okay. So I think we're at a point where anything related to anything that depended on stuff from my other project has been disassembled. It looks like, well, yes, I might modify the parsers further. I think that doesn't matter for this because we only care about very specific aspects of file loading. So, generate preload file. Let's start by loading in the TMX file and make sure it actually loads. So, TMX parser file or map load from file. And let's just see if in general that actually breaks down correctly. We got some narrowing conversions to do. That's fine. Float. Float. That might be new because before they were just implicit casts, but I think some things in the geometry header probably changed to make that not a thing anymore. Okay, so parsed a map. This map has a width of 192. What map is this, please? Well, tell me. Here it will. This is Campaigns 1-1. Classic. Back to the beginning, I guess. 1-1. Okay, we don't use this map anymore, but whatever's in this folder, we're just gonna assume we're generating, so it doesn't really care. It's just gonna do it anyway. Oh, or we could actually read from the levels file of the game. That way we know which levels are actually required. Or I can just delete these. It's like we add test levels in here too, and I guess I don't really want them to be parsed. So in reality, we should also read in the level file. So we have a levels configuration file in our game that I can pull from. This is what it looks like. And it just specifies every map that is supposed to be loaded in the game. And so we can take this and say, okay, load these maps. And only these maps. We don't care about the other maps. That way we're not loading invalid map files. This does require the OLC util data file. So we'll grab that. I'll just grab the latest one from the repo. Sure. Add that in here. Also, I just realized we haven't established a Git repository. I think now's a fantastic time to set that up before we proceed much further. There's the OLC util data file. I'm gonna go ahead and add that in here. Strangely enough, the data file isn't detected or probably not in the right place. I must have done something weird. Oh, everything just goes in here. Okay. Add existing item. Oh, you know what? If this is in the Adventures in Listoria Git repo, it probably just is considered part of that repo, right? Like, let me see. Yeah, it's just part of this repo now. Okay. No, I actually like that. That's perfect. I thought I was gonna have to make a whole nother, like, repo and be like, this is a whole nother program, but no, it's actually part of the Adventures in Listoria Git repo just by existing in the same folder, which makes sense. Set up initial map preloader project, which actually works better. It's like kind of streamlined now. 2 projects existing in one place. Not a totally bad idea, and what I could probably do, and what I should do actually, so I'm not like context switching between 2 windows constantly, is actually, I'm gonna close others. We have too many tabs open, just in general. Way too many tabs. We just have to be careful about files that are named the same thing now, because we do have copies. Is I'm actually gonna add a new project to, well, an existing project to my solution. I just have everything in one giant solution. So the map preloader here is now accessible via this project directly, and we can work in here. I think that's very convenient. And we can hit build. We'll build it specifically for the map preloader. Excellent, we can run the map preloader again. I can put a breakpoint there. Oh, I hit build on the wrong project. Stop. Control, where's... I don't even know where break is on this keyboard. I don't even think it exists on this keyboard. I don't see a break key. Okay, cancel. I literally don't have a break key on this keyboard. It's very tiny. So, yes, set as start a project, build, and then run. Cool. File system, memory, error, location. So this wasn't happening before. Recursive directory. Oh, I hope the working path didn't change now. I feel like it did though. Time to check. Cause you know what? I think... let me see. That wouldn't really make sense though, right? Target directory. Oh, wow. It actually builds in Adventures in Lestoria now. That's kind of crazy. Wait, that's actually crazy. So that means Project Dur is now Adventures in Lestoria? It's an Adventures in Lestoria / map preloader. That's normal. Why is Target Dur weird? See, that's why I'm like, it doesn't sound like what we need. So Target Dur is Adventures in Lestoria x64 debug. That's interesting. Which is obviously not what we want. So I'm going back to... Is that where the executable is built now? Oh, that's fascinating. Wow, it actually is. So that's correct in the sense of that is the new target dir. So I would have to change where the executable gets built if I want to do that, or I just use the target directory and base this on that. So that would be ... /... So one ... less to get to where we want to be. Rebuild. And now it looks like map is parsing correctly again. So, well, the whole reason I did all that is I want the data file now to parse our level file. So we can say level data and then only parse those levels. What meta stuff is project and what is solution is entirely opaque. Right? Okay. So I included this, which means I should have access to OLC, utils, data file, and this is going to be the levels file, which I can open, and I'm just gonna say it's path. It's not quite path. I guess I'm going to have to back up a little bit if I choose to do this. It would be like path here. Let's switch to standard format for a second. Path / / or is it in assets? I think it's in assets. So this would be assets, and then we do config, I think. Adventures in Lestoria, assets, config, levels.txt is what we're looking for. And then that should work. Argument types are standard string. Is that not the constructor? The constructor is, oh, blank. We do .load after. So levels file, it's just the way it was written. .read. And that's when we put the file name. Oh, and we also put, oh, I see, this is static. How strange. It's like OC utils. I kind of don't want to keep typing this, so using namespace we'll see utils. Let's do data file read in levels file. It accepts a reference to it for writing presumably, and the file name, and an optional list separator. But this should be fine. After we read this in, levels file should now be populated with all the level data in that custom OLC format. So if we look at it now, looks like nothing got read, so it looks like it failed. I think read returns a code. Yeah, I think it returns false if it failed. So if not this, we'll just throw and say we couldn't write. Throw runtime error. Could not open file. Okay, so that should actually get called now because it seems to have failed. So yes, it did. And now we have to figure out why. Probably just the wrong file path, I'll be honest. Oh, we did delete the whole... Wait, so path is a variable. That would be nice to put in the right place. Hello Justin the voice actor, welcome. And now, hopefully levels file will be filled correctly. And it looks like it is. So it comes with two objects. The maps for them are map path and levels. And inside of levels, we should see a lot more objects. So 49 from there. And each one maps to a stage name. And the stage names each have the file names. I guess they match. And then we just read the TMX files from there and do the rest. We don't really have to care for the other data of them, just that. So now that we have that information, we can actually choose which files we want to read, and only those files. So let's iterate through, not this anymore, but we will do for, let me see, because I wrote my own custom thing for data file to iterate, but this is the vanilla version, which doesn't have as many things. So it has... If we index into it, I think get value count will have what we're looking for. Number of values... oh wait, no. This doesn't actually have what I'm looking for. Which is probably why I used a custom version of this in the first place. So I may have to pull that up specifically for that function. So if I look in OCUtil data file in Adventures in Lestoria, I've added a few functions that we could find useful. And as long as it doesn't depend on much, I could probably scrap this or use this one specifically, which has much more useful functions in it that I will probably want. Okay. So I'll go ahead and this, and then let's get rid of the stuff that doesn't work. So I don't think I'll need this, as the original didn't need it. Get rid of the error message. VF2D, so we don't need get VF2D. I'm not interested in that. We don't need get pixel. We can get rid of that and that. Some more down here. More error checking. Again, I should just replace these with throws because they are checking for valid things. Yeah, maybe that would be wise. You know what? I have a cool idea. How about, since the error macros are getting used everywhere, why don't we write our own error macro real quick? So just up here, since we've got so many, define error. String will be throw standard runtime error string, or in this case error message. I like that better. Then at least this macro will be fulfilled in all the places where it gets used. It doesn't seem to like it though. Oh, that's right, because we use cout syntax sometimes, so it's really like it's a two-parter. It will output a message and then throw. So always throw. It's just this. I guess this turns into more like a string stream that gets appended. Yeah, it's like we have to define a string stream and then append stuff to it. I guess that was the idea. So looks like I have string stream in here already. So stream string stream error stream, and then we'll do airstream pipe error message, and then output that in here as the runtime error. Still don't like it? Let me expand it line real quick. Oh, we just don't. No instance of constructor. We just have to turn into a string now. So .str. Here we go. Still get rid of that one. Get rid of pixel. And what else? Log. I don't really care for the log. This error doesn't work because it uses standard format. It was like, it will always have a string tied to it, so it's like, if I standard format that, does that not work? I feel like it should. If I just standard format add a message there, how would that not work? Unless, let me see. I'm not sure how that would not work. Oh, I see. This is an if statement. So this would be in its own scope. This is all in the same scope. So let's add a curly brace and another curly brace. Like that. That way if we write code that is supposed to be multi-line, but it's written on a single line, it will actually still be in the same scope. Okay. Funny things, macros. But that should work. And the whole reason I did that was because I wrote a couple of useful extra things, such as the ability to do an iterator containing the key and the size inside of levels file, or whatever sub-access we want of levels file. In this case, we want levels file levels. So it will look something like this, and that will return all the keys at that stage. So I can literally just output that real quick. Standard print line showing the key. You can take a look at that real quick. Basic format is not a constant expression. Right. Here we go. Okay. So key here is campaign 1.4, intro map, boss 2B. It's not in any particular order. This is an unordered map, so they'll just spit out random things until they've all been iterated through. But yeah, that's nice. I didn't know a print line like this existed. Or wait, no, print line automatically has cout. That's right. So should appear in console. It does. Okay, cool. I was like, I thought I had to put standard cout, but that's another version of printline where you can adjust the stream that comes out of it. Alright, so now that we have that, we can call generate preload file based off of the key we obtain. And we just appended the key to the end of this and a .tmx. So it'll be something like standard format. So path plus slashes file.string slashes, or no, .tmx. I guess technically I could read into this more, and I think we get the file name itself. Yes. I think that's actually what we want. So let's go into there and grab map file. So we're grabbing levels file, levels key. So I actually want to change this a little bit to be... So we can also use get property, which lets us start from here and use like a dot syntax. So it'll be levels dot... Well, whatever the key was, .map file. Map space file. My C++ is entirely hobbyist, and it's so interesting to see you solving so many things I've vaguely come across and not mastered. I'm almost keeping up with it all, it's just the right level for stretching my knowledge, like the macro braces thing, but wouldn't have figured it out myself. Oh, yeah. A lot of it just comes with time, right? Like, it sounds like you're definitely not a beginner, so that's good. It's like you said, it's just the right amount to start stretching your brain a little bit more. Learn new things. When I see new C++ code I've never used before, my brain gets intrigued and then I'm like, oh, how can I use this in my project? I try to use it, even if it looks silly. And then I determine, do I like it? Do I not like it? Right? I might run into errors or problems I did not expect. So there is that. So that's good to hear. That's like pretty much how you learn and develop as a programmer. Awesome. So this should be our key. So we got like a format in a format now. That's fun. The first one should be path. Let's file get property, and then we should be good to go. I hope. So let's try this again. Now I should be reading every file or parsing every file that's found in that levels file only. Const eval cannot result in a const expression. Okay, so in that case we need to take this out in its own place and then put it in later. Const standard string map or level file, I should say. Boop. Like so. Insert level file. Oh, I see. The get property is not const. That's why it's complaining. Here we go. And then we want that to be the level file. Oh, actually, this is wrong too, because we have to do get string after this. That's why. I'm like, I don't think it's non-const, so I must have just typoed something. Yeah, there we go. It should have accepted that by default. Okay. I just didn't type it right. I keep trying to use iota and ranges, but end up going back to more standard ways. But I am trying. Yeah, that's nice. It's definitely how you learn and develop. For sure. Okay, it actually doesn't like this. It wants it to be const, so we'll make it const. Fine. It still doesn't like it. Let me see. Path, path, path. Well, actually we're iterating through file right now, so that's not even right anymore. Now we're iterating through all the keys and we're just generating a preload file with the path, and yeah, so this isn't necessary anymore, that loop. Although this standard format still exists, which is what it's complaining about. Parse is not a member of standard formatter. Parse. Oh, that's a path, huh? I had to do dot string, right? Okay. Here we go. So this results in a file with this name, which results in a structure with this data, and that failed. Does this return something when it reads? I don't think so. Yeah, this has nothing in it, so that didn't quite work. Oh, I put .tmx after the .tmx. Right, so that goes away now, because we actually have the file name correct. And okay, now we have a structure with stuff. Whether that's useful stuff yet is a whole another question, but we're on the right track. I guess the most useful stuff will be all the tiles. And the tile set data, of course. But yeah, all the tiles. That will be very useful in a little bit. Okay. All of our file parsing is done. Let's do a good commit of this real quick. Added config and file parsing to select the proper parse levels to parse. Cool. Alright, so we will commit that. Do I want to include the executable? I think that would be a nice addition just to have. I usually like doing it just for sake of having it. Although this is a debug, that's probably why I don't want to include it. Okay, let's commit. And now let's move on to actually trying to get something useful printed out of this, or done with this. Okay. Where to start? Where to start? It's gonna be... This is probably where we will stop mostly for today. I'm just gonna get a small head start, because we're almost out of coding time. So let's try to match something that comes from loading the game. So we're talking about setting up the foreground and upper foreground tile fade groups. Okay, so what the heck does all this do? Maybe it doesn't matter, because maybe we can just run the entire loop anyway. One interesting thing I'll point out though is this is currently divided into multiple executions, I think. Let me see if that's true. Because I see some lambdas, but I think the lambdas are defined in the loop still. So that's fine. Okay, it looks like the next one is split up. So I made a lambda called split up, and then I divided up those tiles, but it's still done in one iteration, so I guess that's fine. What I was worried about was if I had one entire, like, solve, like, divided into multiple iterations, that would be a little more difficult to figure out, but no. So generate preload file. We've parsed the map, so the next thing to do, it looks like, is to set up the foreground and upper foreground tile fade groups. So set up foreground fade groups. That's what I'm going to call this one. We're also just doing very much, what is this called? Procedural programming right now. And we're just coding from top to bottom. Okay, let's see here. So a lot of this assumes we have access to, or we have these like getters here, so we're gonna have to figure out how to substitute those. These are supposed to be map tags, okay, which we do have. They're just stored inside of here, so really we want to pass this on. So it already exists, so we'll pass on a reference to it. I'm gonna assume we need non-const, because I don't think I wrote const correctness back then. So a reference to our map, where we can do something like map, get map data or something, like get data here, which does contain our map data, so that might be close to what we want. Map, what do you got? You do have map data, which is what we're looking for, kind of. I don't think you have a width though. Like, all this might just be XML tags. I don't think I really specialize them. There's a layer tag, XML tag. Yeah. So if I wanted the width, I would have to actually read it from the map data, which I don't think is too hard, but let me see what map data actually consists of. Current document. Oh, wait. Map data is here under a map. It's just private. I'm gonna expose that. Wait. This is the TMX parser for Adventures in Lestoria. Let's not get tripped up here and use the correct one. Okay, this makes more sense. I'm like, huh. So this map just has a raw XML tag. 25 years ago, I worked for a financial institution with COBOL. Procedural seems very natural. Yeah, the classic. Okay. I want to look at the map file real quick, because, okay, so this is the map tag, presumably. It does end, so one of the keys is the width. Right there, it looks like it's specified in tiles, so 200 tiles wide by 122 tiles tall. Okay, good to know. It looks like that's exactly what we're interested in, so get integer width. It looks like we're going to be substituting a lot of these kind of like that. But essentially we end up with the same result. Is it a bit verbose? Yes. In fact, I might go as far as to say if we need to keep doing this, which it looks like we do a couple times, we might even write our own little, like, lambda get current map data to just find and replace this. So it'll be like auto get current map data equals, and we can pass in a capture of our map and just return map.getData.mapData. And that should be all we have to do there to essentially replicate it, the functionality of it, minus the actual get integer part, which is fine. That's not a big deal to replace. Okay, and the map data is the raw map data accessible here. Oh, it's actually the layer data of the current level, which presumably this map is the quote-unquote current level we're working on. So we're just going to access that directly, I think, via map get data, get layer data, or layer data, just in general. And then that iterates through all the layer tags that exist in it. We don't care about the unlock condition because we're just parsing it anyways. That's a game thing. Okay. Yeah, we got a lot to go through. This is gonna be work. So, get tile sheet. This is where the TSX parser is supposed to come in because it's gonna do some funny stuff with that. Presumably, we specify the level and a tile ID, and it grabs whatever tile sheet for that TSX parser it's supposed to use. Let's check if that's true. That's actually the function we've been working on all day, is that get tile sheet function. And yes, it does have a bit of involvement, so considering we modified it earlier, some of this might still actually apply, and we might be able to just use a one-for-one. It looks pretty generic, not too bad. Let's see if we can make it work. It is static, so local const does not apply. Map data. So again, this would be, if we have the map name itself, we should be able to grab what map it's from. Although this is the map name. So I think we would change this to reference the exact TMX parser map directly, which would then give us access to the map data, presumably, consisting of tileset data. Now, I don't think we have this one yet. Oh, we do. Okay. That is a vector of tileset tags, though, which is a little more advanced. We recently did that. So we would have to update our tileset data to accept tileset tags, which we recently wrote in TMX parser anyway, so I think we'll just copy paste what we worked on earlier to there. So if we find our way back to the, I think it's just called the tileset tag right here. Yeah. All this we did earlier, we're just gonna bring it in. So this one, we grab a new tag, wherever that would be, right here. We're looking for, instead of tileset data, we'll just completely replace this here with our own stuff. We just don't have a tileset data that matches, so that'll be a tileset tag now. So tileset tag does exist, we just have to replace the vector somewhere. I don't see you, where are you? Here it is, with a tileset tag. Cool. Now if we go back here, tileset data should be a tileset tag. Although it's a vector of tileset data, I guess that's what it's complaining about again, so this should be a vector now. Okay. It's also just complaining about these, which is kind of weird. Namespace standard has no member S2I. I wonder where that comes from. That's funny. It's probably like string or parse or something. You know what? It probably is string now that I'm looking at it more. But string stream includes street. So let me try standard string or S2I. It is defined in string, and presumably string stream is supposed to provide string, so that's kind of weird. Maybe it doesn't though. Can you get away with string stream without strings? I guess you can, in theory. Alright, so now this is a vector. I'm just gonna delete it. I don't really care too much about that, so I'm just gonna delete that. Do I even care for this thing? I don't think so. I'm gonna get rid of it. Get rid of... Well, that shouldn't be an error in the first place. And... S is a string stream, which... I don't know where these errors are. These are kind of weird errors. Maybe compiling will tell me more. Okay. Parse map data. I'm gonna get rid of that. Don't really care. Are we okay? At least in this file? Okay. It appears there are no more errors in here, so I assume the rest will go away when we clear things up with IntelliSense. Okay. So back over here, we're supposed to end up with a tile sheet data structure. Map tile sets. So this is probably something that's supposed to be stored. Tile colors though, do we care about that? I don't think we do. Like, we removed that actually, didn't we? Yes. I just completely removed it, so this isn't even a thing anymore. I don't know if it really ever wants to be a thing. So that can go, that can go, that can go. This can go. Okay. So far so good. Alright, so now the get tile sheet function is ready for our level, so we're gonna pass in map. And then we end up with tile sheet data. Then we get to do all this. So now the map tile sets structure comes into play. And where does this come from? This is probably just a link into, like, whatever the TSX parser originally did. So we do have to do something with TSX parser. It has to read in any files that the TMX parser knows about. And essentially we have a place where we do all that. It is at the beginning of the game when we're initializing, like, all of our stuff. Somewhere in one of these we do that. Probably initialize levels, if I were to take a guess. It looks like this is close to what we want, as we can even see we're populating the map tile sets structure at this time. So this is all useful, and you can see TSX parser is used there. We're preparing our renderable, which is going to contain the actual tile set image, which we're not going to use for this, but of course, but we can see we even render, like, the mini-maps and stuff. So that all happens here, and that's right after we read in the tile set data for a map. So I'm pretty happy to copy most of this and just get rid of irrelevant stuff when it comes to the parser itself. So this is just a for loop through all tile set data of a given map. So for every map we have to do this. So it's likely in the same place where we're doing generate preload file, we're setting up the TSX stuff at the same time. Some maps may actually use the same tile sets. I think by default, I tried to find it, and if nothing's found, we add to it. So we're definitely gonna have to provide this global structure as well. I think standard string, the key is the map name, which we got from, well, we could use the file name as well. File names are unique, although map name, I think, is how they're stored in map data. But if we match it up correctly, we should be able to also use our own version. Actually, you can see here map tile sets does the assets/map/base source directory thing as well, interestingly enough. But I think we can use whatever. We can just use our map names. Anyways, because file names are unique. We know they have to be per OS rules. So let's see where we're at with this. Actually, I might just call this load tile sets. And we'll go somewhere else, just to avoid more clutter. Just splitting into functional into functions that kind of make sense, like step-by-step wise. That way, if we need to navigate through one specific step, we can be like, oh, everything's in here, and we know it is. So this is a TMX parser map reference. Okay, so instead of doing this, we just do map.data. I don't know why the .data thing exists. It's kind of silly. But anyways, tileset data. This map tilesets thing will have to be made. So let's go ahead and grab that from our here. We'll just make it a global in our actual program. And then we'll start adding to it. Great. We don't need an image, so we're gonna ignore that part. The tile set itself, so it's gonna come from base dir. And base directory was established from like a config file. I think I'll just hard code it because we can. If we're running it from here, then we have to go 2 directories back. Let's probably get a standard format going. So we'll say 2 directories back. Adventures in Lestoria with lowercase I. Going into assets, maps. And then all the... Is this the image file? No, it would be the TSX file. Yes. Well, no, these say there's assets/maps. That's interesting. Each map has a list of tile sets? I find that a little bit bizarre. I think I chose this route because in the actual game, we only load one map at a time, right? So keeping a structure that has multiple tile sets doesn't really make sense. But in our case, it kind of does. So I might have to change where this is actually referring to. Although really, like I said, we could just do map. Map tile sets for map. Tile set data contains all this information. But what about... Let me refresh myself on what tile set data is. Contains an image, which we got rid of. Tile width, tile height. The foreground tiles, the upper foreground tiles. Oh, so that all just gets copied. Okay. From tileset. Understood. But then again, I asked the question, what if we have the same tileset for another map? Do we just reference it again? Is there anything different? The tile width and tile height, like this is all tied to the TSX parser, so this is all data exclusive to one tile set. So I think it makes sense that the map tile sets refers to the TSX file, so we don't have duplicate tile sets stored in our game. I like that. So that's what we will do. This also hints at what we're gonna have to do to kind of serialize and store it away. Is we're gonna have to say, okay, for this tile set, this is the data you care about versus another tile set, right? But maybe the TSX stuff is still gonna be loaded anyway in game. I feel like this stuff is not very... Well, seeing this like foreground stuff, this is what... that might be okay. This is like what tiles are going to fade away. They go in the foreground tiles or upper foreground tiles data structures respectively. Okay. I think it's a very safe assumption here to make this be the map name .tsx. And I don't actually know if we can get that information. If I'm being for real. Yeah, I don't know. But yeah, from tileset data, we would be getting... Well, now wait a minute. It says assets/maps, but it's using map data? I guess I want to now see what value this is actually producing, because if it's from source, right? Oh, I see. Because it's going to use the source, and the source has all that information. If we review it one more time, we're looking at these again. So these do refer to the TSX files. So even though I say assets/maps, then it's gonna be like, okay, backtrack now, because this is a relative path, then go into /maps/whatever.tsx. I don't know why it's done that way, but it is. But yes, here we are. So I guess leaving it like this is fine then. I like that. I just have to make sure we're grabbing from the right tile set. So again, this is the actual file name. So maybe instead of calling this base source dir, how about we call this the tile set name, tile set file name? I'm like, what is base source dir? It's not even a directory. Cool. You can see we're about to get into the meat of it, so I'm actually going to call it here for tonight, and we'll continue next time. Had a lot of fun working on this though, and we're going to continue now that we're kind of on the right track to making something out here. I hope you all enjoyed the stream today. It's been a lot of fun. We'll be back tomorrow to continue working on this. It's going to be quite a huge project, hopefully with a good payout in reducing the load times of the game to essentially nothing, as all the map processing gets done here in this little program we're writing. So yeah, thanks for tuning in and thanks for subbing once again. I really appreciate it. And you all have a good day or night wherever you might be. Take care. Bye.